There we go. Okay, I think we're on. Let me know, can anybody see or hear me right now? Excellent. Well, everybody, welcome back to Paleontologizing. Welcome back to a very windy day out here in northern Montana. We're digging up some dinosaur eggs and some other stuff out here in the Judith River Formation, kind of old man formation equivalent. Montana. Now, if it's your very first time here, welcome. My name is Danny Anduza. I'm a dinosaur paleontologist, and believe it or not, this is how I make my living nowadays, doing science outreach live streams on Twitch, rain or shine. Well, not really rain. Yesterday we got rained out of the site, so we had to end a little bit early. Today, hopefully, we don't get thrown over the horizon by these strong winds. We'll have to see. Live broadcast. Anything can happen. But yeah, as a paleontologist, I study fossils. As a dinosaur paleontologist, I mostly study dinosaur fossils, and that's mostly what we're finding here. I'm working with the Badlands Dinosaur Museum of Dickinson, North Dakota. Every summer they come out here to northern Montana and find all kinds of cool fossils. This year I've been lucky enough to join up with them, and it's been kind of cool. Really, really neat little reunion. I used to work with some members of this crew, namely Denver Fowler and Liz Friedman Fowler, pretty much every summer back when I lived in Montana. And this is my first season coming back out to work with them since 2017. So, yeah. Neither of them are at the site right now, but we're going to say hello to Steve Clausen, who is at FossilPreparator on Twitch. He's leading this crew right now as we excavate some duckbill dinosaur eggs and whatever else we can find. So during the course of this live stream, if anybody happens to have any questions, do not hesitate to ask them. Put them right there in the chat. The whole point of these streams is to do science outreach, to show you what field paleontology is really like. Wind and all, I guess. Very windy today, so we're gonna make the most of today's stream. I'm glad you're here. And good evening to you too. Well, it's afternoon here, Kevin, but welcome, welcome. Nell says, I think I prefer Montana's landscape to Wyoming's. They've both got pluses and minuses, but yeah, out here in Montana, it's certainly a lot less dry. You can see we've got a reservoir behind us there, and the landscape is a lot more green. They do tend to get a lot more precipitation up here than that part of Wyoming does. This is agricultural land, so this is what we call a coulee in this part of the world. So kind of an incised river valley here, lots of erosion. You go up top, and it's all canola fields and stuff like that up there. So we have farmers' fields today. And yeah, the beautiful sedimentary rock that is highly fossiliferous. Welcome, welcome, Prince and Internet. And if anybody wants to help contribute to these live streams, you could subscribe or gift a subscription. Or you could donate to the Badlands Dinosaur Museum as well. They run a really cool operation. They're not a huge museum, but they punch well above their weight. And well, hopefully you'll be seeing some of that today. So, welcome to Paleontologizing. I'm glad you're here. Good stuff. Oof. So here's the site over here. We're doing our best to not let the wind get us down. Same site as yesterday. One of the big eggs that we had yesterday, we have now jacketed to protect it. But hopefully we'll find some more stuff live on stream today. There might even be some photogrammetrizing happening and some other stuff. We shall see. But here's boss man Steve over here. How you doing, Steve?
Hey, pretty good.
Yeah. You want to introduce yourself to any folks who might be new there in the chat?
Hi, I'm Steve Clausen. I'm a field crew chief and lab manager at Badlands Dinosaur Museum. We're all a team. We represent North Dakota, but we have people from all over the, I'll say all over the globe.
We'll do a quick little crew roster. Ed, where are you from?
I'm now from, well, Rockford, Illinois,
Okay.
and Phoenix, Arizona.
Nice. Yeah. All right. Illinois and
Retired engineer.
retired engineer. I didn't know that, Ed. Very cool.
Yeah.
Yeah. So we've got Illinois and Arizona represented here. Wag, where are you from?
Originally California,
Yeah.
and I reside in New York.
Nice. Cool.
I'm a former superintendent of sewage treatment plant.
Nice. Yeah. We were talking about that earlier. My Uncle Dave also helped run a sewer plant in California.
Oh, yeah.
Yeah. And then we got Brian from Casper, Wyoming here. Biologist.
Former archaeologist, turned science teacher in the last 8 years. Field and lab person at the Tate Museum in
Nice.
Casper, Wyoming.
Awesome. Shout out Tate Museum. Yeah, thanks, Brian. And then over here, we've got a new crew member here today. Care to introduce yourself?
Yeah, hi, I'm Neo from New Jersey. I'm a data scientist. Yeah, first time here.
Nice. Yeah. So we've got New York and New Jersey represented. Deanna?
Hi, I'm also on FossilPreparator, the Twitch channel with Steve.
Yeah.
I'm FossilPreparator from Massachusetts.
Nice. Yeah. And then we've got Laura over here.
Hello.
Yeah. Where are you from, Laura?
I'm a Montana native, and this is my second year digging with these guys.
Awesome. Yeah. And then Gabriel.
Hello, I'm from Puerto Rico.
Hi.
Yeah, and this is my first time out in the field with the crew.
Awesome. Yeah.
Yeah.
So Gabriel just showed up last night. So our crew roster is growing. And yeah, we were just talking a little bit about Puerto Rico. Cool stuff. Got a good crew today. Which, you know, we often do. But yeah, cool people. Cool people. Anyway, so yeah, we're working here in the Judith River Formation. The big cool egg that we had on camera yesterday has now been capped, so Brian took care of that. So beautiful. We can kind of rest easy knowing that that's not going to get destroyed by wind or rain, at least not unless we get torrential rain.
So now I'm digging around to have it up on a pedestal so the burlap all the way around, and then we'll channel under it so we can flip it over.
Nice, yeah. And it's lucky that that's not going to have to be incorporated into that jacket. It'll be separate. So
Yeah.
easier to move and makes our lives a little bit easier. Yeah. Yeah, cool. So anyway, yeah. Again, don't be shy about questions today. I'm going to try and make today's stream a little bit more interactive than some of the past ones have been. So again, if you have any questions at all, do not hesitate to ask them. But a little bit of background about this area. So we are in northern Montana, just a few miles south of the Canadian border. And this, I guess, is part of the Milk River, which comes down from Canada and then feeds into the Missouri River. This area is famous for its dinosaur fossils, whether we're in northern Montana or in southern Alberta. There are so many different kinds of dinosaurs from here. But the eggs from this area are not very well known. So the stuff that we're excavating right now, these what we think are Lambeosaur eggs from a dinosaur like Lambeosaurus, one of the big crested duckbill dinosaurs. They produce these huge eggs, and yeah, we're excited to collect some of these and do some science on them. And then we've got lots of other little pieces and bits of things showing up there too, from coprolites, which are little fossil poops, to bits of turtle and teeth from various dinosaurs. Lots of bone chunks. We have what we think is a small juvenile, or like, you know, small subadult little hadrosaur in there too that's kicking out bones here and there. So it's a cool site, a nice kind of illustration of the different critters that lived in this environment. And we're trying to figure out the depositional setting, what kind of environment this was, and all of that. It's a little confusing so far because things are pretty badly jumbled up, but it's good stuff. And Raymond Dino says, is this an eroded old layer of soil? It actually is, yeah. So this site represents what we call a paleosol, 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 which is just an ancient soil horizon. So the way that we can tell that it's a paleosol is that, well, there's all kinds of roots going down into it, like fossil roots from about 76 million years ago, give or take. Little burrows and things like that. So clearly this was a pretty stable environment. We're not talking about like a lake bottom or a river channel or anything. A paleosol is... let's preserve the soil. Let's turn the rock. Well, good stuff. And yeah, there are little bits of plants. I might even have some for you here. I set some aside, but they may have been thrown around. Any roots here? Let's see. They don't look like much, but there we go. There's a little bit of root right there. You know, from the Cretaceous period. See that brown streak right there? So we get a lot of that in these horizons. There's some more here too. And there's some more plant material there. So yeah. And that's cool, says Baby. I think so, yeah. You know, I love that I can show simple things like that to you in the chat and people go, oh wow, that's really neat. Because, you know, we just truck that stuff down the hill. We find so many little roots and stuff like that. If there were one that were really well preserved, then maybe we could identify it down to like family or genus level for a particular plant, but typically the plant people don't really look at fossil roots, as I understand it. So it's not particularly diagnostic, it's not very scientifically useful. And if we brought home to the museum every last little scrap of plant material and stuff, you know, that museum would fill up fast. So we've got to be a little bit more choosy about what we actually collect. Also, it's a lot of work to carry that stuff up the hill and back to the vehicle. So, you know, we try and only collect what we really need to in order to help tell the story of what this environment was like. We might take photographs of some of those roots. We'll definitely write about them in the notes, like you've seen Steve do yesterday. But yeah. Oh man, this wind. And herb sticks is what kind of dinosaur did we find? So we think it's the eggs of a duckbill dinosaur like Lambeosaurus. It's a duckbill with a great big crest on its head. It's kind of hatchet shaped. But oh man, this wind. It's really something. Yeah. But yeah, this wind is not kidding. You're totally right, Claire. Yeah. And rushwing, these eggs are more bird-like with hard shells. So they would be constructed of like aragonite. And actually, let's talk to Steve about that for a minute. If he's not too busy. Collecting like this in such high winds can be really tricky, especially when you're using things like toilet paper or aluminum foil to wrap your specimens. So sometimes it's a two-person job. Exactly, that's what I was just saying. So,
This looks like a thoracic or a dorsal rib.
Oh, nice.
An individual of that growth stage. So we found a couple dorsal vertebrae already.
Nice. I was just talking about this,
identical.
like a small juvenile or maybe subadult hadrosaur.
Yeah, something like a yearling. This is about the right size.
That's the top part of the rib where it connects to the vertebra right there.
Yep.
Yeah, nice.
So we're just keeping it out in pieces.
Pretty decent preservation.
Yeah, it's
egg
not
site,
bad.
yeah.
And this was pulled out of Neo's little pit there.
Nice. Fresh find?
Fresh find.
Yeah, very nice.
And because it's windy, there's only a certain way to do this.
This is why I like using aluminum foil rather than toilet paper. It feels a little bit less sketchy and high
If
wind.
it's something really friable, like a tooth, I do use toilet paper and then I foil over that.
Yeah.
In this case, I may have done it, but this wind just is prohibitive with the toilet paper.
Do you guys get the non-perforated toilet paper like the paleontologists use?
We have perforated stuff, but sometimes the non-perforated roll just makes its way in one way or the other.
Yeah.
So
Well,
I have no idea
the
what's going
paleobotanists
on.
prefer it for wrapping all those fossil leaves up like mummies. It
Yeah.
it doesn't come apart.
When we find a nice big plant or a set of leaves or
yeah.
lily pads, we jacket it.
Yeah, nice, yeah.
That's just my instinct.
Do whatever you got to do, you know?
Yeah.
The fossils
So-
come first.
Yeah, I get this mapped and bagged and tagged.
Uh-huh.
So we have a marker where this came from, and we have
Nice.
a Jacob's staff I can use
Uh-huh.
to get the measurements of its height and orientation.
Nice.
But I'll bag it up first
Cool.
so it doesn't fly away.
Yeah. So that documentation, like Steve was talking about, is really, really important, especially for a site like this. We're finding things at different horizons, so at different heights in the rock layers. And so those might represent different times, or it could be that there's just a bunch of mixing going on. We're trying to figure that out, like how much bioturbation was there. Bioturbation is just a fancy word for like when a living thing churns up the sediment so that some stuff gets higher and some stuff gets lower. Things get moved around, some sort of split up, they might get stomped on. That's all bioturbation. Yeah. Thank you, Claire. Excellent. Didn't know there was a Wikipedia page for that. Beautiful. I think we had another question in the chat. Let me look at that. Let's see. And yeah, so Claire, we think this is maybe about 20 miles inland from the coast at this time. It's hard to tell exactly, and like the exact shape of the Western Interior Seaway and where the shorelines were, they fluctuated a lot during the Cretaceous. So it's always changing. And it's actually really debated, like how far we are from the shoreline and stuff. Denver's got strong opinions on that. We will talk more about that maybe tomorrow if I'm at the Jack's Bone Bed site, because Denver should be digging there. But yeah, oh man, we're probably getting 40-mile-an-hour gusts right now. I hope everybody's tents are okay back at camp. Man. Knock the hat off. I know, and this is a new hat, so it's not really like, it doesn't fit as well as it would when it's really broken in. It's a little too loose. A leather hat like this should conform to the shape of your head. But this one's new, so yeah. I'm almost willish, but I hadn't retired my old hat after 17 years. But yeah. Anyhow, yeah. We'll take a look at some of those copper lights that, those are always fun. Here we go. So coprolites are fossil dung, and these are mostly really small. They don't look like crocodile coprolites to me, which tend to have kind of a spirally shape. These are more kind of amorphous. They don't really look like a particular sort of shape or anything. So we've been tentatively referring these to baby hadrosaurs, so little baby duckbill dinosaurs leaving these little poops. It would make sense if this were, you know, a nesting ground for these critters. The stuff would accumulate. But yeah, eventually we'll collect these, bag them up, and then they could be of, you know, real scientific value. We don't have anybody on this crew, or I think at the museum right now, who works on coprolites, but it'd be a nice thing to have in the collection, just a little box full of them if anybody wants to do an analysis at some point. Steve, you were talking about this earlier. What kind of analyses can you do on those little coprolites?
Well, because there's so many of them, you can do, you know, what some people call destructive sampling. What we like to call specimen enhancement.
There you go.
Because data enhances the specimen, right?
I've said that so many times. It's nice to hear it from somebody else. MOR philosophy almost.
So, like, when you section a limb bone or something, you cut a piece off of it, you put it under a microscope. That's histology. In theory, you could just cut a section out of one of them, make a slide, and let's see if there are any like small fragments of plant in there or something like that.
Yeah.
Seems like for one reason or another, this site, the conditions weren't great for preserving plant material, for anything that's carbon or carbon stained.
Right.
You could also like grind a coprolite up into some powder. You could do like an NIR, that's near infrared spectroscopy.
Cool.
And that'll give you, abundances of, certain presumed elements and compounds. Or you just go and you hit it with XRF or handheld X-ray fluorescence. It looks like this barcode scanner, but it shoots out X-rays, so you can't be too close to it. But that'll just tell you, this is how much phosphorus is in here relative to this and that. And what if we see something weird, like there's a spike in gold? Was there a certain plant back in the Cretaceous that took up gold, a little more readily than something else?
Sure.
Like
we're talking about trace amounts. We're not talking about like gold rings or anything.
Right, a heck of a lot more trace than would normally be there. You talked about the berries. What if they're eating some kind of berry? We have a modern analog, and there's a higher gold than you'd expect. That sort of thing. And I'm sure there are so many people that'll have more things to say about poop, because there are poopologists out there.
Coprolithologists, like Karen Chin is surely the most famous. I wonder if she'd be interested in any of this stuff. But yeah, cool. Thanks, Steve.
Yeah, no problem.
I don't know. It's exciting to like pick up little bits and pieces of things and go, well, this doesn't look like much right now, but it could yield some really interesting data in the future. So that's why we do this. But yeah, remember, dung analysis, specimen enhancement. Oh yeah. But yeah, I've said that many times before. Like, long-time viewers have heard me say this. There's this idea of like destructive analysis, where like you cut open a limb bone to be able to count the growth rings inside of it, or you grind up part of a tooth to be able to run isotopic analysis. And a lot of collections managers, the people who are in charge of what happens to the fossils back in the museum, a lot of them are a little bit reticent to allow that kind of study, because part of the specimen does get, I guess, destroyed maybe. But that's the reason why we find these specimens in the first place, is to study them, They're not art objects, we don't just get them because they look pretty. We're digging up these fossils because they provide us with information. So I don't know, the term destructive analysis sounds very negative. The folks at Badlands and some of my other colleagues, we prefer terms like enhanced sampling or specimen enhancement, because we're using those specimens to garner information. It's the whole point, Holy cow, this wind. And thank you, Drunky Kong. Oh boy. Yeah. And Ramadino wants to know if Steve has been called to retrieve fossils in a mine. I don't think he has, but we'll ask him. He has done some like paleontological remediation. So like construction site monitoring and that kind of thing. So we can ask him about that. Yeah. And Pumpkin the Cat says, I guess the argument could be that in 10 years there will be fewer and less invasive ways to analyze the samples. Yeah, that might be true. And that's a valid argument to make, but I don't know. Much of science is very time sensitive, and I don't know. I was trained at Museum of the Rockies, and so was some of the people who lead this operation out here. And our philosophy was always, well, we can go out and find more fossils. It's a very fieldwork first kind of approach. You know, if you don't go out and find more fossils, then you won't have things for the collections. And you can't be too precious about the specimens that you have. Like, if you're going to do science on them, that might, you know, require you to, you know, take core samples or grind a few things up. You know, it's like you got to crack a few science eggs to make a science omelet, you know? You can't be too precious about these things. And if you're cutting up specimens or grinding things up eventually, it means you need to go out and find more. And there's no shortage of fossils in this part of the world. There are things eroding out all over the place. So all over this landscape, there are fossils that are just being destroyed by wind and rain. These things are not uncommon. And the more we go out and look, the more we find. So I don't know, we don't like to have too much of a scarcity mindset about these things, if that makes sense. Yeah. So yeah. But try telling that to some collections managers, you know? Especially if they don't do a lot of field work. You know, and they have valid points. You know, I'm not... But I think you know where my bias lies, you know? Yeah. And Trick Track says the fossils seem very close to the surface. How long do you have before they erode? So we find the fossils while they're eroding out. That's how we discover these things in the first place. Find little bits and pieces that are, like right here. Lovely example. Here is some fossil bone, dinosaur bone, presumably. Just right here on the surface, scattered around. So when we find a new site, this is often what it looks like. Fragment of bone like that, spilling out. So when we're out for, and then we follow it in, we try and find the source, you dig into the hill, and does that make sense? So erosion it's kind of the best friend and the greatest enemy of the paleontologist. So it allows us to find fossils in the first place, but sometimes you arrive a little bit too late and the specimen is just kind of destroyed by erosion. That happens quite a bit. So, yeah. Erosion, the paleontologist's frenemy. And Yoda on Coke, you do have a point there, yeah. Paleoanthropology used to be a field where, like, there were more scientists than there were fragments of ancient human fossils. Like, there were literally more scientists than fossils. It's not quite the same anymore as they find more and more specimens. But here's the thing, is that human evolution, when we're talking about, you know, even genus Homo, the human genus, it's only been around for a couple million years. Whereas dinosaurs were around for about 178 million years, give or take. Much, much longer. And, well, yeah. There's a lot more dinosaur fossils out there, and they happen to be all over the world, on all 7 continents, including Antarctica. So sometimes dinosaur fossils are incredibly rare in a certain area. Like in California, where I'm from, there's not many dinosaur fossils. So even a little scrap can be really scientifically important, or at least it feels very precious. But in a place like Montana, there are dinosaur fossils that are going to be scattered all over these Badlands here, just everywhere. And some dinosaurs are rarer than others. Some are more scientifically interesting because they're just less common. But if we're talking about dinosaurs in aggregate, they're everywhere out here. If you know where to look, and if you know how to identify them and excavate them. So yeah. But yeah. Okay, let's go ask Steve about his remediation work. If he's ever been called into a mine in order to find fossils. I certainly haven't. But Maybe Steve has. Yeah. Steve, we got a question from the chat for you. I know you did some paleo remediation work at one point.
At one point,
Yeah.
once upon a time.
Had you ever been called into like a mine or anything like that in order to find fossils?
No, not a mine, but
Construction sites, maybe?
well, plenty of construction sites.
Yeah.
One thing that comes to mind is Rancho La Brea style material. So
yeah.
not in like the Rancho La Brea sense, like the Page Museum.
Yeah.
Los Angeles had the Purple Line extension.
Uh-huh.
I was one of the mitigation paleontologists
Oh,
on
really?
that.
Nice.
Where we had
Shout out public transit.
yeah, shout out. We had like saber-toothed canines falling out the ceiling. I'm not kidding.
Mine? That's super cool. Wow.
Yeah.
That's awesome.
Yeah.
So if anyone's in LA and you take the Purple Line, know that you're going through a spot where you used to be Smilodon just coming out of the ceiling.
Yeah. Among,
Really
I mean,
cool.
mostly like direwolf and
Yeah,
some mishmash and
More common
things that aren't really herbivores.
Yeah.
That's memorable in terms of what's maybe being in a cave or not. Mitigation itself, just
Yeah.
that industry.
Yeah, it's tough, but like that's how a lot of, especially younger paleontologists, make a living. You got to take jobs like that, whatever pays, you know.
Right.
Yeah.
Right. As long as it's healthy for you.
Exactly. Yeah. So cool. But now you're here, so I don't know, something worked out.
Yeah. This is where I prefer to be. I wish I could show myself a picture of this, and then I'd be happy.
Yep. Yeah.
Yeah.
Like, keep on chugging, you'll get there.
Yeah.
Yeah. Cool. Thanks, Steve.
Oh, you're welcome. Thanks for being here.
Yeah.
And hi, chat.
Yeah, I mean-
just saying hi, chat.
It's fun, isn't it? Yeah. So Steve also streams on Twitch, or did until a few months ago. He's on a bit of a hiatus after becoming a homeowner. Holy
Yeah.
cow. Congrats.
Yeah, and building a new consulting lab.
Yeah.
Basically gutting the basement of that house and building in dust extraction and everything.
Yeah.
My intention is to get back to that in September, at
Nice.
the end of the field season.
Yeah.
So I'll be back.
Very cool. We'll have to raid in. Maybe I'll be at Lori's site in the Cedar Mountain, have a bunch of viewers, and we can raid into you.
Sure.
We'll see.
That sounds
Yeah.
good to me.
Cool.
Yeah.
Cool. So everybody go follow FossilPreparator if you're not already doing so. I know a lot of people from this community already follow Steve and Deanna on there, but they do really cool stuff. And I'm always trying to encourage, more science on Twitch. This is such a wonderful medium for this kind of thing. Oh yeah. Go follow at FossilPreparator. And there you go, Wombat Hole. Yeah, he definitely does know a thing or two. Yeah. And Drunky Kong. See, this is, I don't know, we're really lucky to have Steve here because he does always have something insightful to say. Maybe unlike me. I'm just being self-deprecating. But yeah, no, the wind really is something, Claire. Oh boy. This is one of the reasons why I'm not setting the camera down so we can work, because the wind would just blow it right over. It's nearly ripping the camera out of my hand right now. Yeah. But so it goes, Yeah. And yeah, the BC, man, we're actually on Bureau of Reclamation land right now. So this is public, I think, federal land. So it's not legal for private collectors to collect fossils here, not vertebrate fossils at least, because these belong to the people of the United States. They're not for private ownership. In the same way that you would need a special permit to go like hunting or fishing in this area, you would need that for fossils as well. And we have permits from the Bureau of Reclamation in order to be able to collect here. Those cover vertebrate fossils, so bones, teeth, claws, things like that. But I suppose if you were to collect, I don't know, plant roots or snail fossils, that'd be fine. As long as you don't take too many. There's special rules about that kind of thing. But yeah. But it is very windy here, Digital Seahorse. Yes, indeed. yesterday, but thankfully, much less rain so far. We'll see how the rest of the stream continues to go, but yeah. And oh, that's an excellent question from Princeton Interda. We can talk about that. Let me sit down over here, maybe away from the wind. I'll try and sit on. Is it called the windward or leeward side if it's not facing the wind? Is that leeward? Somebody look that up. We have any sailors in the chat? We've got a question about birds and teeth and beaks. And this is a really interesting question. Oh, that's so much better there. The question was, why did birds develop toothless beaks? It's a really good question. So birds evolved from small two-legged meat-eating dinosaurs. Think like Velociraptor, with those sharp teeth. And the first birds did have teeth. You look at critters like Archaeopteryx, and they had teeth. Little dinosaur-like teeth. They're essentially like a tiny little Velociraptor, Archaeopteryx. That's what the first birds looked like. But at some point along the way, birds lost their teeth. Well, what happened? Well, it's kind of a complicated story because there were a ton of different species of birds with teeth during the Mesozoic era, during the age of the dinosaurs. But only the toothless birds seem to have survived when the asteroid hit 66 million years ago. And Ephraim Tour says, shout out to my Uncle John. There you go, Ephraim. Yeah.
Danny.
Yeah.
Bone.
Oh, we got Bone here? Here, let's pause this answer for a minute and go check this out. Oh, Deanna, what did you find?
I don't know.
That's the exciting part. It's just bone. I don't know what it is yet. So
Awesome. Let's take a look.
tell me. Hopefully it's part of this yearling we're taking out, but it's bigger.
Ooh. Oh, look at that. Very nice. Yeah, so right under Deanna's brush right now. Got a bone there. What could that be?
I don't know.
It looks almost kind of flat like a scapula or something.
It looks either pelvic or something like that.
Yeah. I can see it being part of like the brevis shelf or part of the pubis or something like that.
Oh yeah, I could see scapula and scap or pubic.
Yeah. Here, let me get my laser pointer out so I can point at it for the chat.
Posterior process of the ilium. Look how like bulked it is.
Right there. And then is this bone right here too?
Yeah.
Yes.
Nice. So it extends from here
Yeah, and this part peeled off.
along to here.
Super spongy and
That's the
friendly.
discovery field there.
Nice. Okay.
Like especially ilium or something,
That
that
explains
is the
dorsal.
Uh-huh.
that'd be consistent.
Be part of that same individual. Nice.
Like as a project.
Excellent.
I wanted eggs.
That means you're gonna have to take down a bunch of this shelf up here, the wall.
Sure does.
Yep.
Oh, Brian.
Wow.
You all right, buddy?
Oh, you're right, Brian.
Yeah.
Trying to avoid going
Nice. Let's see what the chat says. Yeah. Frozen Yak says +1 for the women again. I mean, yeah, we've been.
Okay. Sure.
Team Lady finding all kinds of cool stuff here in the forum. Gender wars thing.
Had a leg up and the gust hit me. And I
Nice.
kinda lost
Cool.
my
We'll
balance.
check in a little bit and
Alright, sweet.
see how this progresses. Thanks, Deanna.
Hope that things are all right.
Awesome. I haven't found anything 100th as good as that so far. I've been digging up here,
'Cause I started up over there.
just trying to get this down to the proper layer. But I don't know. I've got a stream for 3 hours in the afternoon, so you know, I shouldn't really be in a productive layer to start with, taking up valuable real estate. But yeah, pretty cool. That's one of the neat things about doing this live. It's like you never know what's going to happen. What kind of cool things will we find while the camera's rolling? But yeah. And Linus says, huge thank you to the team for allowing us to tune in and watch this live. Absolutely, yeah. Here, back to that question about birds and teeth and losing their teeth. Yeah, so the question is, like, why is a lack of teeth an advantage? So dinosaurs, like most animals that have teeth, constantly replaced their teeth all the time. They're not like we mammals who, we get 2 sets of teeth during our lifetime and then we're done. We get our baby teeth and then our adult teeth. Dinosaurs are not like that. They're just constantly churning through sets of teeth all the time like a conveyor belt. New teeth would erupt out of the jawline and out of those alveoli and push the old teeth out just constantly. And birds were the same way until certain groups of birds just got rid of their teeth and developed a keratinous, what we call edentulous beak, instead toothless beak. And that may have actually provided a key survival advantage to them. There's an idea that when bird embryos are growing inside of the eggs, if you can cut a few corners and make it so that development happens faster, and so the embryo spends less time vulnerable inside the egg and instead can hatch out sooner and grow into an adult sooner and be able to fend for itself. If you can sort of jettison some parts, like, no, we're not doing the tooth thing anymore. We're done with that. We're going to shave a couple weeks off of and spend less time as a helpless egg. That's one idea for why they did that and why that strategy succeeded, is it allowed them to hatch faster and thus be less vulnerable to getting eaten or the eggs cracking or whatever, So as far as I know, that's kind of the leading hypothesis at the moment for why birds developed toothless beaks, or at least why the toothless birds happened to survive and the toothed birds had a harder time and they died out. It's a difficult hypothesis to test. It's one of these things that kind of verges on being a just so story. Like, oh, that makes sense, I guess, but like, how do you falsify it? How do you try and demonstrate that it's true or false? How do you test it, I don't know. I'm not an expert in this. I don't study fossil birds, but yeah, I don't know. Puggawoga says, why do birds have hard-shelled eggs? That's a good question too. I think they're probably just a little bit more resilient having a hard shell, and it probably helps retain moisture better. Because the animals that have leathery eggs, they often tend to live in more moist environments. You think about critters like crocodiles, turtles have leathery eggs. These are animals that are kind of semi-aquatic. They're often nesting in areas where, it's a lot more moist than, say, like an ostrich who's laying her eggs in a desert, essentially, or out on the savannah. It's a much drier environment. I would think that critters like crocs or turtles would have a more difficult time keeping their eggs moist in a drier climate like that. So yeah. And peak optimization. There you go, Yodon Cook. Yeah. Another funny thing with the bird beaks and lack of teeth. There's some evidence that suggests that the birds that died out at the end of the Cretaceous when the asteroid hit, at the same time that all the other dinosaurs went extinct, that those birds, that they mostly fed on either plants or on meat, the toothed birds. And in a scenario like that where an asteroid hits and just collapses the food chain, good luck finding, lots of plants around to eat, or fruit, when there's no photosynthesis because the sun is blocked out by a nuclear winter scenario, essentially, an impact winter. There's evidence that the birds that survived the KPG extinction were ones that were mostly eating seeds, because seeds are pretty resilient. They last for a long time. So if you can survive on seeds when you eat them with your beak, that may be the key survival ingredient to surviving an asteroid apocalypse like they did. Again, it sounds convincing. It sounds like it makes sense, but testing that hypothesis is easier said than done. So yeah. Yeah, and it was about 90 to 95% of bird species went extinct, Charlie's Dragon. We almost lost birds during that extinction event. Same with mammals. It's like 90% of mammal species were killed off. Only a small fraction of mammal diversity survived that event. So, yeah. Let me try to get out of the wind again. This is a little ridiculous up here. Here, we'll go check in on Deanna for a second. And we can talk about quarrying strategy too. Like, which direction do you dig? Over here. So during an excavation like this, this is something we have to teach new crew members. Deanna is a veteran here, absolutely, so she knows what she's doing.
It doesn't look great right now. I'm gonna be so real with you.
But
well, maybe we can grab a finer brush just to get some of the
No, like
junk off of it. I mean, it's going in.
and here, there's the bone right there.
Wait, is that more bone up there?
Ooh, do we have more bone?
Does it go in? I don't know what it's doing.
it rounds out. Yay!
It rounds out.
Oh.
It looks like a condyle.
Oh, whoa.
I hope it's not.
Is that all the same bone?
Yes.
Ooh, does it go in?
It's a big old limb then, maybe.
It's gotta be a. We're playing the game here.
Yeah. You know?
It goes from scapula to pelvis to vertebra.
Oh!
There's too much
Is
wall.
it widening out toward me?
No, it's staying the same.
Huh.
No, it's just kind of. I don't know.
That's a limb.
Weird.
I mean, it goes down 3 feet.
Strange.
Yeah, we have to figure
What is
out
that gonna
exactly
turn into?
what.
Very caution.
Oh, that'll be another jacket.
So see how it's going into the wall there, Chet?
You gotta
so
take all that
Deanna's,
down.
yeah, she's gonna have to dig down from the top. You know,
Oh, this foil to come out.
it can be very tempting to dig what some crews that I've worked with call it a rat hole, where you just kind of dig straight into the wall.
Are you seeing what I'm seeing from the side, Deanna? How it's all. How there's a.
But you can't do that. You got to dig down from the top. When you dig into a wall like that, it's things can collapse. It just gets really messy. You have to dig in from the top down. That's good practice. And that's what Deanna's going to be doing. Yeah. And remember, Deanna says, how much could be dug? Would it be possible to dig through the entire hill? Do we have a permit to dig the entire hill if we want?
Technically.
Nice. Yeah.
Like, I mean, what it is that you don't want to stagger too far before the eggs are coming out.
Yeah.
Keep going.
Yep.
Keep going.
So we'll continue to follow the eggs and the bones as far as they go. Steve was hoping to close out this site this year, or even like within the next week or so. I don't know if that's going to happen now. We'll see, because we keep finding more stuff. But yeah, we keep excavating until this stuff runs out. That's kind of the name of the game. Yeah. And Puggo Wuggo says, if any non-avian dinosaur were to make it through the mass extinction and survive to today, what group would it have been? That's a good question. I don't know. Birds survived, so my not very exciting answer would be, well, whatever group is the most bird-like without being a bird. You know, it's almost, you can almost imagine like troodontids or something surviving. Or dromaeosaur, probably more troodontids. I picture them being kind of generalists, so maybe even eating plants in addition to meat. Little clever little guys. I don't know. I could also imagine like a Lystrosaurus type scenario with something like Leptoceratops. They were digging burrows. eating roots and stuff. Can almost imagine them surviving, but yeah, I don't know. It's an interesting speculative question, but no, I don't think T-Rex is the answer. At the top of the food chain, like, it's a vulnerable spot when you have a food web collapse. I don't know. We can ask Steve what he thinks. Chad has been very complimentary about the insightfulness of your answers thus far.
I'm so. I try my best.
But we had a question: if you could imagine any kind of any group of non-avian dinosaurs somehow making it through the KPG, what do you think would be most likely?
Something tiny and dumb.
Yeah. Yeah.
Kind of thing. Can I speculate, like back into the Cenomanian or
Sure.
something like that?
Go for it.
Like if Psittacosaurus were still around.
My answer was leptos, maybe.
Okay, yeah, leptos.
Yeah, I could totally see that.
Yeah.
Especially if they're eating roots and stuff like that.
It's
And
not something exciting. Like,
yeah. Okay. I like that we had the same kind of thought process there.
Yeah.
I said maybe also like troodontids if they were if they learned how to burrow or something, that might give them another advantage. But yeah.
I mean, they had brains, right?
Yep.
Yeah. Maybe not enough to say if we burrow, we'll survive the extinction.
Sure, yeah.
Right?
But also with a big brain that comes with certain metabolic requirements.
Yeah.
You got to eat a lot of food, and in that sort of a scenario, you want to be able to kind of wait things out and fast for a long time.
Yeah.
So I don't know. Yeah.
A new tooth has been found.
Oh, we have a new tooth. New tooth. Yeah.
No, I don't want to.
Oh,
No.
tiny. Look at that.
Yep.
Little theropod.
Yeah.
Can't quite see it from this distance, but chat, you identified for me, huh? Very nice.
That was Laura.
Excellent. Well done, Laura.
Team lady. Woo.
Yeah. There you go.
This is team lady.
That's what he called us. Do you want
Better than the other name for this
Yeah.
little piece of foil.
We've got the
Yeah, it could be,
Get a
Pago.
little piece of foil and
I've got some
micro.
I've got
Nice.
more than enough for
So I would show that to you another time, but we want to make sure this thing is wrapped up ASAP. We do not want that blowing away in the wind. So I hope somebody clipped that. But yeah, I could see that being a dromaeosaur tooth, maybe. I didn't see the serrations on it, Pago Wago, but could be. Again, like we said yesterday, troodontids tend to, at least stereotypically, they've got really, really big serrations compared to the size of the tooth. And that's not what I was seeing there. But yeah. Anywho. Very cool. So yeah, dromaeosaur is like Deinonychus there, Ephraim. And Frozen Yak says, is there any technology under development that would help you guys find the fossils easier? Maybe some kind of pharmaceutical or something? I don't know.
Yeah. We already have caffeine pills. Yeah, I've seen.
Yeah. And electrolytes, yeah.
Yeah, I think any of that technology that's speculative would just be more damaging than it's helpful.
Yeah.
So, no, and I don't want that. We can do it this way just fine.
Yep.
Like we get it out safely.
Yep.
This is good. This is good for all time.
It's one of the most common questions I get, like when I'm doing fieldwork, is like, oh, do you guys have some kind of ground penetrating radar or magic laser beams or something to find the fossils? And
Well, sometimes we have magic laser beams that help map the quarry.
Yeah.
They don't really help us find anything.
there you go. You're talking about LiDAR or?
Yeah, sure. Yeah, that's also laser texture scanning, 3D scanning.
Nice, yeah. But that's basically for just documenting the shape of the quarry rather than finding bones.
And that sort of thing is usually done to the specimen back when it's at the museum.
Yeah.
Today, like by the end of the day, I want to do photogrammetry, which involves blowing all the stuff off the hill with a leaf blower.
Nice.
And then we just use a cell phone camera and photogrammetry software on site.
Cool. Yeah. If we don't get rained out, hopefully I can document that while you're doing it. That'd be neat.
Yeah, I'm not seeing anything at the moment, but we'll see what comes our way.
Nice. Yeah. So again, to return to the whole ground penetrating radar thing, that doesn't work. Particularly because the teeth and everything else, they're often incredibly small. And there's so many other things that the ground penetrating radar would pick up before it picks those up. Like, you know, these rocks right here. These big, like, concreted ironstone, sandstone blocks. Like, these would show up in that kind of a scan, and the bones would not. So, tried, and it's never worked. That gizmo that you saw at the beginning of Jurassic Park, you know, a few more years development, we won't even have to dig anymore. That was 1993, and that technology didn't work back then, and it doesn't work today in 2026. Sometimes there just isn't a technological solution to a problem, and I know that's really difficult for a lot of tech people to hear, and I'm not trying to make anybody cry, but, you know, sometimes it just takes a keen human eye, and there's no improving on that. Yeah. Especially since there's just a million zillion variables. Like, when we find a fragment of bone here, you know, sometimes it just takes like decades of experience to know, well, okay, it's a fragment of a transverse process from a subadult hadrosaur. You can tell based on the texture and based on just kind of the way it feels in your hand and all of that. And I'm not ever be able to do that kind of thing. It hasn't yet, and yeah. But anywho, and also the idea that like we would want something like that, like, I don't know, I feel like especially nowadays during this like AI bubble, people think technology is that good. 50% of the time it's not. Like, often it's a bad thing. There's such a good, like, there is such a thing as good, you know? Efficiency is not always a positive thing. Where humanity thrives. It's important to remember that technology is meant to serve us and not the other way around. You know, if certain technologies are taking people's jobs or, you know, otherwise making life more difficult for people, then get rid of it, you know? It's not worth it. I know that's it feels like slaughtering a sacred cow for the tech industry, but it's the truth, you know? Not every problem requires a technological solution, and not all technological solutions actually solve real problems. Anyway, this is me getting philosophical here, but yeah. Anywho, and how are you all? We're doing well, Mothproof KT. Yeah. Today was supposed to be town day for the crew, but many of us have just arrived and don't really need to have a town day, don't need to take showers or do laundry. You know, I just got here the day before yesterday. So many of us elected to come back to the site and work today, especially since we got rained out early yesterday. So yeah, we were eager to come back and find more cool stuff. Yeah. And here, let me go walk over to a part of the hill where it's a little bit shielded from the wind, and we'll continue with the Q&A here. There we go. Let's see if this is better. Oh, okay, that's much better. Excellent. Yeah. Musso says that is a big sky. We're in big sky country. Montana, baby. This is what it's like. A question from Akira Eclipse. Thank you, Claire, for reposting that. How do you know when you found a new species of dinosaur? When do you decide it's different enough to be classed as its own species? So this is one of the great, like, subjective things about paleontology. Maybe especially dinosaur paleontology. It's the sort of thing that we as paleontologists argue about all the time. Sometimes it's easy if you find something that's just totally weird looking. I'm talking about like duckbill or Limusaurus or some other weirdo critter like that. You know that it's new. And sometimes it comes down to stratigraphy. So like the dinosaurs that we're digging up in Wyoming last week, it's almost a certainty that many of those are going to be new species because they're from a time and a place that hasn't been explored before. So they're from a particular sequence of rocks that represent a brand new time. They're a blank spot on the map. And so, since dinosaurs tend to evolve pretty quickly, they don't stay the same for long, we can safely surmise that they will be new species. That's not good enough for a publication. In order to be able to demonstrate that, we have to compare the fossils that we have to fossils of, other dinosaurs that have been previously discovered. So you compare details of their osteology, like their bone anatomy. And at the end of the day, it does end up being kind of subjective. Like, are these differences strong enough to actually warrant a new species name or a new genus name? At a certain point, that kind of becomes a matter of opinion. There's no, necessarily hard and fast set of rules, like, oh, well, if it's 97.8% different, then it's a new species. It's not like that. And that's because biology itself tends to be squishy in more ways than one. Biology is complex. There's lots of interesting things going on. There's a zillion different variables, and biology tends to deal with more of a spectrum than with a binary sort of thing, and especially when you're dealing with geological time, when you have animals that are evolving over millions of years, if you have one lineage evolving over time, at what point get your finger in it and go, this is a new species right here at this exact moment? No, it's a spectrum. They're slowly changing over time. So to answer your question, how do we determine if something is a new species? You do the best work that you can and you try and come up with as much objective data as you can, but there is a lot of interpretation there. And I realize a lot of folks are kind of uncomfortable with that idea, but that's nature, Nature abhors a binary. It's full of spectra, Lots of interesting, beautiful gray areas in between. So yeah. Anywho. But yeah. And howdy, Filippo. It's good to see you here. Welcome, Dyson Dinosaur. Hope you're doing well. Let's see. Do we have any other questions? Are Denver and Liz here? So Liz will be arriving on Friday now, it looks like, and Denver is currently in town. I think he's watching a soccer game. The World Cup. He wanted to take today as a town day to take showers and do laundry and catch the game. So many of us didn't want to do that, so we elected to come here and dig instead, even though this is designated town day. So yeah. European vibe is strong. There you go, Dyson Dinosaur. Yeah. And I will send them your regards. Yeah. Hopefully, I'll have Denver on stream tomorrow. I think I'll be visiting the Jack's Bone Bed site and streaming from there. So unless we get rained out, we'll see. You never know out here in the field. It's hard to predict things. That's part of what makes this exciting, Yeah. And Zool says, does it happen often finding varied fossils from different periods of time in the same dig area? If you're going to find fossils from different time periods, that means you're looking at different layers of rocks. And there are certain places where you can find, say, fossils from the late Jurassic Morrison Formation, just below in the rock layers, fossils from the earliest Cretaceous Cedar Mountain Formation. There's places in Utah where you can find Jurassic fossils and then Cretaceous fossils in the layers above. That being said, that sort of thing is not as common as you would expect. You get that in the Grand Canyon, where you've got just a half mile vertical of rocks there from different time periods. But that being said, that sort of thing is not very common. Yeah. So like, if you look around here, all of these rocks in this coulee are from the late Cretaceous period. About 76 million years old, something like that. The older ones are at the bottom, younger ones are up top, but we're not dealing with a huge time jump or anything. It's just, yeah, if that makes sense. But yeah. Oh, and question from Discord. Thank you, Claire. Do you have a single or maybe two books you would recommend for someone willing to wanting to get educated in the early Cretaceous? Dinosaur Frontier by Krista Sadler is a book that I would highly recommend about the Cedar Mountain Formation. And I say this with a certain degree of self-servitude, I guess, because I'm featured in that book. Krista did a little interview with me, and I'm included in the text for that. But Dinosaur Frontier by Krista Sadler. Good stuff. Yeah. Yeah. That's about like the early Cretaceous, Cedar Mountain Formation of Utah. As for other books about the early Cretaceous, there's probably a book about the dinosaurs of the Isle of Wight in the UK. And that would also be early Cretaceous. There's Bob Bacher's novel, Raptor Red, which is like a fictionalized version of the Cedar Mountain Formation, early Cretaceous. It's a storybook. It's goofy, but it's fun. A lot of people like that book. Yeah, hopefully that's enough for you. But thank you. And, oh, and very cool, Charlie's Dragon. I'm glad you liked Dinosaur Frontier. Yeah. An interesting Puggo Wuggo. Okay. And you love Raptor Red? There you go, Cthulhu. Yeah. Yeah. That was one of my favorite books when I was a kid. Yeah. Oh, and Bernissar Iguanodont by Pascal Godefroy. Nice. Dyson Dinosaur. Thank you. Yeah. But yeah. Pate says, I've never heard of Raptor Red. That sounds interesting. Yeah, it's a novel told from the perspective of a Utah raptor. Yeah. A period piece with dinosaurs. I mean, kind of, and yeah, period piece from the early Cretaceous period. Yeah. Should we read Raptor Red? I should too, Dyson Dinosaur, although it might kind of destroy the magic. It's been decades since I've read that. I've brought it out with me to the field multiple years working in the Cedar Mountain Formation and just never read it while I was out there, but maybe this year. Yeah. Anywho, good stuff. If anybody else has got any questions, don't hesitate. Seems like the wind has died down a little bit. Let's go back to the quarry. See what else we can see. And just wait. The wind is going to pick up immediately when I stand up. Let's see. Anything new and exciting over here? Working away.
We want to get a trench through there. It's just there's a very good chance there could be something right where they're putting their hands.
Yeah.
The theme of this site has been we know what the jacket's going to be, and all of a sudden there's just eggs. Eggs everywhere. Egg under that
Just
scoop
like pickup
there.
sticks.
Yeah.
Yeah.
So maybe we'll be able to get that rock out and take that as like a. There will be at least 4 complete eggs in that.
Nice.
Like
Just in that jacket right there?
Yeah, there's some splattered egg here and there. But I'm thinking I'll prepare it upright. So we usually flip jackets to move them. We have then we just prepare them from the bottom down.
Yeah.
That's because they're the best preserved from the bottom down. But in this case, this is how it was laid. You know? Maybe like taking a bird nest and flipping it upside down and putting that on display. It doesn't make sense to me. But if there's another find, it might be here today. You don't know.
Like at the same time, you want to have a clean trench.
taking this down, but I've stopped for now.
Yeah.
Because these guys need a very clean working area.
Nice.
So they can see what they're doing, especially because we don't have the sun out.
Right, yeah. Neat. There you see Deanna working down from the top again. She put some foil over that bone so as to protect it. And so yeah, she's just basically got to take down that whole layer until getting down to where the bone is. And that's the way we do it. Looks like there could be some rain. Is that heading this way or not? That looks like rain. And it smells like rain. Some cold wind there. Might just get the edge of this if it drifts to the east. We'll see. There's a lot of looking at the weather radar in a place like this, doing this kind of field work. Like, what's over the horizon? Is this going to miss us or is it going to hit us? All of that. It's about a mile's walk back to the truck. So if we do have to scoot, it'll be pretty sudden, like yesterday. But I don't know. I think this might mostly miss us. One can hope. And how did the rain yesterday go? Did you all get soaked? No, it wasn't that bad. Within a couple minutes of me closing the stream down, we had all our stuff packed up and we're walking back to the vehicles. So we didn't get soaked. We were more concerned about the fossils. If we get drenched, it doesn't matter. You know, we can dry off. But we don't want the fossils being ruined by rainfall, especially when it's stuff like, you know, delicate eggshell and that. If that gets hit by a bunch of raindrops, it'll swell and it'll crumble. So it's the sort of thing we're trying to avoid. So we made sure to put the tarps over the site and just protect everything. And luckily it was pretty dry when we got here in the morning. There's only like a little bit of mud that we had to wait for to dry out, and then we were good to go. So yeah. That's more important than streaming. Exactly, Pate B. Yeah. It's funny when you're dealing with rainfall when you're out in the field. There's always the feeling that like, oh well, if we wrap things up here and get back to the vehicles, the rain will stop by the time we get there. But if we sit here and wait it out, it'll just keep going and going and going. So at some point you just have to make a decision and roll with it, you know? And yesterday we chose to skedaddle. So, and I don't think it was the wrong choice. We definitely did get some rain when we got back to camp. And a whole lot of wind. Holy cow. The tents were not happy. Part of my rain fly got pulled out of the ground. The stakes just came right up. So I had to hammer those back in. But yeah. And Pogo Wogo says, I just realized the Troodon holotype was found in this formation. Yep. That original tooth. Joseph Leidy published 1856. Would be cool to find more bones. Yeah. There are some troodontid remains that this museum has dug up before, and Denver could tell you more about those. Actually, let's ask Steve real quick, because he'll know about it. But, yeah. Here, Steve, we got a question about troodontid material at the museum from this formation. I remember seeing some stuff in one of the field reports in a previous year, but...
So we have at least one individual troodontid coming out of our site, Jack's Bone Bed.
Nice. Well, hopefully it'll be tomorrow. Yeah.
Yeah, that's where he'll be tomorrow. It is probably Dinosaur Park Formation proper.
Ah, okay.
So more of what's called Judith River here still.
Uh-huh.
So expect some cool Dinosaur Park fauna to
Awesome.
be coming out of that.
Yeah.
Yeah, we have scapula, one of the first known coracoids.
Oh, cool.
North American troodonid.
Okay.
We have a number of limb bones, hands, and also skull bones. So
Nice.
I think we have 2 frontals.
Uh-huh.
Diana prepared a brain case not long ago. We have a
Nice.
whole brain case.
Okay.
And some other things. We are building a skull and a skeleton. So
That's exciting.
Now at these nesting sites,
Uh-huh.
Diana's Dead Baby site is one we have on state land nearby.
Uh-huh.
And this one, we find a lot of small troodonid teeth. And that is also consistent with the description of the nests from the Upper Old Man Formation.
Gotcha. Okay.
Another one of those consistencies, I think that's
Well, you think
important.
this is probably Upper Old Man rather than like actually Judith River?
Yeah.
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 Do we know where Joseph Leidy, or no, actually it wasn't Leidy, it was Hayden found the first troodon tooth. The description is based on in 1856. Is that from the Judith River proper, or just do people just say that?
Oh, I know Denver would know this one.
Okay, we'll ask him tomorrow then.
I
Yeah.
have no idea.
Yeah. Okay. Cool. Yeah. But anyway, long story short, we do have troodontid material from this area, and sounds like you're doing some really cool stuff with it. So
Yep.
that'll be
Yeah,
neat.
It's spread over a whole swath of channel sandstone. That includes the Pygmaeus darkid we have.
Oh, nice.
Probably similar to Montana's Darko, but
Yeah.
it's much more complete and probably something different.
Really exciting pterosaur. It's
just
not
all
easy to find.
Spread over meters and meters. So it takes a while to dig these things up.
Yep.
You know, so maybe it was a year or two ago we had internal discussions. You know, do we just get literature out on the pterosaur? Like, you know, do a description. And,
Yeah.
You know, the consensus was stuff is coming out every year.
So just wait a little while, find more bones, and then.
Yeah, in a couple years we found like 60% of the material.
Nice.
You know,
Holy
so
cow.
It's, you know, it'll come out at some point. But,
Yeah.
You know.
That's exciting.
It's getting,
Shoot.
Yeah, more and more exciting, including potentially our first cranial element is being
Nice.
in the lab right now.
Yeah, yeah. Exciting. Shoot, do you think it's going to be a new taxon?
Yeah.
Oh, that's exciting. Yeah. Awesome. Thanks, Steve.
Yeah.
Yeah. Very cool. So again, I hope that makes it clear that this sort of work takes years if you want to do it properly, you know? You go back to a site and you just keep digging more and more, finding more and more elements. A lot of these things you can't rush into publication. And it requires a certain degree of commitment. You got to keep going back to the same site with crews and just keep digging, you know? But eventually it pays off. But yeah. Oh, and Puggo Wuggo, yeah. My undergrad advisor is the guy doing that, the proposed neotype for Troodon, and I'm totally on board with that. I think that's great. Dave Verricchio, I think he's actually petitioning the ICZN, the International Code of Zoological Nomenclature, to be able to designate a neotype for Troodon, and I like it. I like that idea a lot. So yeah. Oh, and anonymous gifter, thank you for that gift sub there. I really appreciate that. Yeah. Thank you for your generosity. You are as generous as you are mysterious, anonymous gifter. Good stuff. But yeah, I personally, just from an aesthetic standpoint, I like the name Troodon, and I like the idea of continuity with that name. That whole family of dinosaurs is called the Troodontidae, the Troodontids. And it'd be nice to be able to keep that. I feel like it'd be less confusing than giving the group a new name, but in order to do that, you have to make sure that the name Troodon is valid. And by naming a more complete specimen as the name-bearing specimen of Troodon, you can help preserve that name, you know? Because right now, the name Troodon is based on a single lousy tooth. Well, it's a pretty little tooth, but a single tooth is the name-bearing specimen for Troodon, and the teeth are not particularly diagnostic, not in the way that we would like for such an important name. So by taking the name Troodon and saying, hey, this more complete specimen from the Two Medicine Formation. This is what Troodon looks like. This is what everybody should compare their purported Troodon material to. This is the gold standard. This is Troodon. I think that would be really helpful. So I'm all for that. And it looks like it's going to work, so that's exciting. Yeah. And Zool says, how deep do you plan on digging at each site? Is it locked at a certain depth? So we dig until the bone stops. Bone or egg or whatever else that we're looking for. So here, there's a certain depth, and below that we haven't been finding anything. So we're not going to dig any deeper than that. I can show you over here. And I'll ask Steve, too, about the 3-meter rule or 3-foot rule or whatever it is. See what his standard is. And here at this site, we've got these eggs in these plaster jackets right here. And then down where Brian is sitting, we haven't really found anything deeper than that. So that's probably going to be the maximum depth that we'll dig for this site.
Well, let's hope.
Yeah, well, we'll see if anything else turns up deeper than that. Yeah. We basically dig until we don't find anything anymore. That's how it goes. In terms of lateral extent, Steve, do you do 3 feet, 3 meters beyond the last bone? What's the general rule with this crew?
Determining the lateral extent of the quarry.
Yeah.
I let my quarries determine themselves, really.
Sure, yeah. No, I mean, so with MOR, our old rule was, I don't remember if it was 3 feet or 3 meters beyond the last bone. You dig there, if you don't find anything, you stop.
So, it depends on where I am.
Okay.
In the past, so our Holger site, for example, a skull of a Daspletosaurus, it's all gnarly, it's all bitten up, it's huge. We're currently doing the reconstruction, hired a guy. We had fragments of skull that'd be 5 meters apart that clicked together like it broke yesterday.
Shoot.
So because it's a Daspletosaurus skull in the zone that we're studying, we went, we went up to 6 meters in directions, finding nothing.
Okay. Yeah.
Just because finding every single element of that skull was super important.
Yeah.
It's like here, I don't want to say, oh no, we missed an egg, you know, so we're not gonna knock down the whole hill. Maybe, as eggs appear over the years, that's something we might do. But here, I'm gonna say that, about going in a meter with nothing is gonna be what we do.
That's real college.
Yeah.
Okay.
The biggest question was depth, because as we go deeper, it's just occasionally something is cropping up.
Yeah.
So where do we stop depth-wise?
Sure, yeah.
Because eventually we have to widen this out. So the reason the quarry is cut as is because this margin of the hill on that side had a lot of eggshell spitting out.
Yeah.
This hill behind you had a lot of eggshell spitting out, but then it just stopped.
Right.
So I just connected the 2 points, figuring, okay, we might have a line of eggs going this direction.
Sure.
That's more or less what's going on. The question is there more that way? And that's what people like Ed are answering right now.
Yeah. Nice. Cool. Good answer. I like that you let the site determine it. I mean, that makes the most sense.
Yeah.
Rather than having a hard and fast rule.
Hard and fast rule, yeah.
Yeah. Cool.
Vibes.
Yeah. You feel it out,
Yeah.
So much of paleontology is like that. It's like, you just kind of feel it out, see what happens. Yeah. Yeah. Hope that makes sense, chat. Drunky Kong says, yeah, we like that guy. In reference to Steve.
Oh, really? I thought they hated me.
What's that?
They thought they hated me, that's why I left.
No, not at all. No, they really appreciate the answers. Yeah. Yeah. Cool stuff. Thank you, Steve. And Science Streams, how are you doing, Balinth? I hope you're someplace warmer and less windy than me right now. But welcome to Montana. I hope you're doing well. And let's see. From Cthulhu Hates Hugs, I've been away from stream for a few days. I'm hungry for any updates on this new ceratopsian find in Wyoming. I don't have many updates to give you. I got a call the other day from Ken and Ethan asking for advice on how to flip that jacket. So I should probably text them at some point and ask them about it. But they were gonna flip the big jacket and try and get it down the hill. I don't know if they've done it yet. But yeah. And then the original ceratopsian site, not Purple Puzzle, but the one we call the ceratopsian site. That one, I've heard the crew is making like rapid progress in taking down all that overburden. So that big, back wall that you saw, all the guys with the jackhammers and everything, they, I think they're almost done taking that wall all the way down. So way ahead of schedule. So hopefully they'll be down in the bone layer very soon if they're not there already. And hopefully they'll be finding more bones from our original ceratopsian. But yeah. Being up here in Montana working with a different crew, I haven't heard much. So I'm sorry I don't have much news to share. But yeah, I think when I get back home to California at the end of the month, we'll call in, we'll maybe talk to Ethan, maybe talk to Logan after he's done some prospecting, and we'll get some updates on that. Should be exciting. And there you go, Mayor's Fish. I'm glad you're in a place like that. Yeah. Confused, admittedly. Oh, I thought you meant find. But Finn, you mean frill, maybe? A different word that starts with an F. The ceratopsian frill. Yeah. Yeah, that jacket hasn't been opened up yet. It won't be for a few months, at least. But when it is, we hope that most of the frill is in there, because that is kind of the most important part. Yeah. Anywho. And next dinosaur-based movie, we'll see. Demos Norum. It'd be nice to get a Hollywood paycheck, but I'm not holding my breath. Anyhow. But yeah, good stuff. We've got just shy of 400 people watching right now. If anyone's here for the first time, welcome. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm out here with a crew of paleontologists and volunteers, digging up dinosaur bones and eggs and teeth and etc. in the Judith River Formation, kind of Old Man Formation equivalent, near Havre, Montana, USA. It's very windy, which is why I'm kind of crouching on the leeward side of this hill. Is that how it goes? Let me look this up. Leeward side. Windward and leeward. So upwind, downwind. So downwind is leeward. Yeah, there we go. Yeah, I'm on the leeward side of a hill right now, trying to escape this relentless wind. It's breezy today. Yeah, thank you, Mayor Space. Yeah. Huh. Yeah, let me know if you've got any questions. Believe it or not, this is how I make my living, is by doing science outreach live streams. A lot of paleontology focused stuff. I'm trained as a paleontologist. I've been digging up dinosaurs since 2011. Almost every summer. I've only missed one or two because of COVID. But it's nice to finally be back out in Montana streaming live. I lived in Montana for the better part of a decade. And I used to come out here and do field work every summer with some of the people from this museum. With Denver Fowler in particular, whom many of you will be meeting for the first time tomorrow on stream. Denver is running the Jack's Bone Bed site. I think Jack Wilson discovered that a number of years ago. And we've got all kinds of cool stuff coming out of there. Troodontids and pterosaurs, like you heard earlier. Tyrannosaurs, hadrosaurs, duckbill dinosaurs. I think there might be some ceratopsian pieces. It's kind of a nice smorgasbord, kind of a tasting menu of the various big cool critters that lived in this environment 76 million years ago in the late Cretaceous period. So that's going to be a lot of fun. Going to be a different vibe from this site here. Much bigger quarry. Here we're all kind of you know, together cheek by jowl, working at this little egg site. Tomorrow, at the other site, you'll see it'll be different. So yeah. Anywho. Blindside 16 says, I'm in the Idaho Panhandle. I know there are a lot of mammoth fossils uncovered here. Any active dig sites in Idaho right now? I don't know of any in Idaho. In fact, last week when I was in Wyoming, we had some paleontologists from Idaho show up to help out with our dinosaur excavations in Wyoming. There are some dinosaurs from Idaho, but not a great deal so far. Ooh.
We had a little rock sort of fall from close to the top of the hill there.
Yeah?
And sometimes you just have like a little curved piece of eggshell.
Nice.
This
Look at that right there, chat.
You know, it would have been part of a whole egg that
Yeah.
was either hatched or crushed or mulched in the Cretaceous, and
Yeah.
you're just left with that.
That's awesome. Shoot, thanks for showing us, Steve.
Absolutely.
That's really cool. Dinosaur eggshell there, 76 million years old, give or take.
Yep.
Awesome. Yeah.
Yeah.
Thanks, Steve.
Yeah.
Yeah, appreciate it. It's nice not having to get up to see the fossils. That's a new experience for me. Yeah. What was I saying? Oh, Idaho dinosaurs, yeah. There are a few dinosaurs from Idaho, and the team from Pocatello, from the Idaho State Museum, is that it? What's the museum called in Pocatello? We had a few paleontologists visit us from that museum. Rob Gay and Tut Tran. They came out to visit us. Yeah, they're going to be hopefully digging more into the Wayan and Blackleaf formations. It's from like the late part of the early Cretaceous, and they've got what they think is a giant oviraptorosaur because they have eggs from a giant oviraptorosaur. They've got what looks like a tyrannosaur and an ankylosaur and maybe an iguanodontian dinosaur. And of course they have Eryctodromeus, the state dinosaur of Idaho. The burrowing runner, the digging runner, Eryctodromeus. So yeah. But yeah. Yeah.
I don't have a phone.
Oh, and Nana, how are you doing? Love you, Nana. Good to see you. Sounds like you are pretty busy. Oh man, I am, yeah. I spent the latter part of May in Florida working with leatherback turtles, and then from the beginning of June until the middle of the month I was in Wyoming digging up dinosaurs, and now I'm here in Montana digging up more dinosaurs with a different crew. I'll be in Utah in mid-July to early August. I'm hopefully going to be doing more leatherback turtle fieldwork in Monterey, California in early September. And maybe I'm going back out to Utah after that to dig up more dinosaurs. It's going to be a busy summer. But it's good to see you, Nana. I hope you're doing well. That's my grandmother in chat, everybody. Love you, Nana. I hope you're having a good day. Yeah. But yeah. And Landon History Buff, are you interested in the End of Oak Street movie? I haven't heard much about it. I don't know. I've been busy. But yeah, there's dinosaurs in it, right? I'm sure I'll see it at some point. Yeah. Cthulhu Hates Hug says, by the way, let me tell the crew here. Here, I've got a chatter who just said, by the way, my 11-year-old just scampered into the room and asked what I was watching. So I told him, and his face lit up, and he said, like Dr. Alan Grant in Jurassic Park? He was stoked. Yeah, we're doing this in real life, though, you know? This isn't a movie. Digging up dinosaurs for real.
People told me I look a lot like him.
Yeah. You and Sam Neill could be twins.
Yeah. Same age, everything.
Yeah. Good stuff. We'll have more bones and teeth and eggshell and stuff cropping up, so stay tuned. If you're just tuning in, Deanna over there has got a beautiful little duckbill dinosaur bone underneath that foil, so she's working down the rock around it so she can excavate it properly. And then we've got some dinosaur eggs inside of these white plaster jackets here to protect them from the elements. So Wag and Brian are working on trenching around this. so we can safely extract those. And everybody else is just kind of exploring around, looking for stuff. So if you have any questions, don't hesitate. We're here to answer them for you. Yeah. Oh, Shark Geek says to you, Steve, you just need to carry around a claw to scare kids with, and the image is complete. Steve's last name is Claw Son, so yeah. The son of Claw.
We got some nice big Tyrannosaur claw casts from
There you go.
Denver Tyranno. I can just have a bulky thing hanging here.
Exactly, yeah. Good stuff. Oh boy, that wind. Here, let me hide from the wind for a minute. Luckily, no rain yet. I think the rain clouds missed us, which is nice. It's more over there. And I don't know, with the wind this strong, sometimes you'll... and then it never even hits the ground. It just gets like blown over the horizon. Yeah, it re-evaporates before it even hits the ground. And Galrock says, how big were these eggs roughly? The one that we were looking at yesterday seemed abnormally large. So we're talking like at least grapefruit size, maybe volleyball size for some of these eggs. Really, really big. We're not really sure why, but it seems like the Lambeosaurine hadrosaurs, so the duckbill dinosaurs with the great big crests on their heads, even though they tend to be smaller than the other group of duckbills, they laid much larger eggs. And that's what we were seeing yesterday. We had a diameter of like, what was it, 27 centimeters or something? For some of these eggs, they are a little squashed. So they might be, by virtue of being crushed, they might extend further out. But at any rate, they are big eggs. You know, way bigger than a chicken egg. Way bigger than an ostrich egg, too, we think. So yeah, and dinosaur eggs front, exactly, Petrodactylus, yeah. Anywho, good stuff. And Drunky Kong says, we want to see you dig. I'm not going to be doing that today, I don't think. Just because if I set the camera down, the wind will blow it over, and I am not risking breaking this camera and having to go home. So we'll have to wait for a more calm day before I can set the camera down. Sorry. It's just how it goes. But yeah, Mayor Spaces have never laid an egg even half as big. I know, right? Get on their level, Mayor. Those duckbills were laying big eggs. Yeah. But yeah. And camera equipment is expensive. This camera is not particularly expensive. I got this on eBay for like $50. It's an old Sony action cam. But I'm a long way from home, and I do not have a replacement camera on me. Yeah. And what was it? Last summer, at the beginning of the field season, we got a scratch on the lens, and people would not stop complaining about it. So I don't want to go through that again, even risk scratching the lens. Yeah. And Justin says, how do you tell the differences between dinosaur eggs? That's a really good question. So in dinosaur paleontology, we come up with names for different shapes of eggs. And sometimes, you know, like we have names like Spherulithus for spherical shaped eggs, Elongatulithus for elongated eggs, that kind of thing. We have a general sense for which groups of dinosaurs laid which shapes of eggs, and sometimes that's informed by actually finding dinosaur skeletons on top of the nests. So a famous example of this is in Mongolia. There's some Oviraptorosaur specimens, like Oviraptor, sitting on top of the nest. So you actually have a skeleton of a dinosaur matched up with the eggs. So we know that this dinosaur corresponds to this shape of egg. In a lot of other cases, it's kind of a mystery who laid the eggs. But you can look at the shapes of the eggs and also the structure. So you can look at the eggshell texture. You can look at the kind of microstructure under a microscope. and you can make some inferences about that, but it gets tricky because eggs are often what we call kind of plastic, meaning that they can change under different conditions. So the same dinosaur laying its eggs in a very dry environment or a more moist environment, the eggshell might have different be a different pattern. The thickness of the shell and stuff like that. So it's interesting how these animals could adapt. It also makes things a little bit more difficult on us because, well, do the differences in the eggshell structure have to do with different species? Or is this like the same species just laying eggs under different conditions? It's tricky to say. So it doesn't necessarily make things easy. Yeah. And Mark Melbourne, thank you for those gift subs. 5 of them. I really appreciate that. Thank you for your generosity, Mark Melbourne. There's 5 lucky chatters who won't have to watch any ads for the next month, thanks to you. And I'm sure they appreciate that as much as I do. Thank you, Go for Fluffernut, for resubscribing. I appreciate that. Yeah. Good stuff. And, oh, is that my mom in the chat? Mom, how are you doing? Paleo Mom 357. I hope you're having a good day. Out here in Montana, things are good. It's very windy today. I'm kind of hiding from the wind at the moment. But I'll show you around the quarry in a minute. Hope you're doing well, Mom. Good stuff. And Sin City 72 says, should come dig in Nevada. The weather is great. I might do that this year, although it would be in the fall. And I'd be up in the Augusta Mountains. And it would be very cold. So we'll see. That probably won't work out this year, but maybe it will. I don't know. Be digging up ichthyosaurs in the Triassic. But yeah. Good stuff. An Awkward Cyborg, thank you for subscribing. Good stuff. Yeah. And Murph, what's shaking with you, Murph? I hope you're having a good day. Welcome back to Montana. It's good to see you. Yeah. And Awkward Cyborg, 15 months. Thank you for the prime there. Excellent. Victorious, tier 3 sub there. Thank you very, very much, Victorious. Holy moly. Do we have a hype train going right now? I bet you we do. Awesome. Let me walk you around the quarry a little bit more. I apologize for the wind if it gets bad, which it probably will. Ooh. Here we go. Again, if you're just joining us, I'm digging with the Badlands Dinosaur Museum crew out here in northern Montana. We're only a few miles south of the Canadian border. Digging in late Cretaceous rocks, and we've got, under those big white plaster jackets, we've got several dinosaur eggs, like from a duckbill dinosaur, a big plant eater. And we've got various bits of bones and other things. We've got, well, here I can show you some of the other critters from this environment. We have a clamshell right here from a Cretaceous clam. Again, this is about 76 million years old, like all the fossils at this site. We've got various snail fossils and things like that. Some more clamshell right here. Yeah, we had some really lovely snails. I'm not sure where they went. Things do kind of get lost in the shuffle. Not immediately collecting them. But, oh, thank you, Steve.
Got a couple right there.
Oh, that's beautiful. Yeah, gorgeous little snails. These are terrestrial snails, so from the land. Very nice. Yeah. Pretty cool.
Oh, yeah.
Nice little picture of different critters that were living in this besides just the dinosaurs. No, everybody gets really excited about the dinosaurs. I certainly do. But we're here to gather as much scientific information as we can about all the critters from this ancient environment.
Got a theropod tooth here as well.
Oh, beautiful. Holy cow. Lovely little meat-eating dinosaur tooth right there. That looks like a dromaeosaur, maybe.
Yep.
Yeah, so like critter like Velociraptor or Deinonychus. Very nice. Thank you, Steve.
A Caroraptor.
Yeah, very cool.
Yeah.
Awesome. So yeah, pretty cool. Yeah. So that's why we're working slowly and carefully with hand tools at a site like this. We're not bringing in a backhoe or a tractor or anything. You know, it's slow and steady wins the race out here. That's how you find little things like that theropod tooth. Yeah, awesome. So glad you got to see that, chat. Super cool. So yeah, if you have any questions for me or any other members of the crew, do not be shy. We'll do our best to answer them for you. But man, it is nice that the wind has died down a little bit. Hopefully, I don't regret saying that. But yeah, we're here near the town of Havre, Montana, working in the late Cretaceous Judith River Formation. So these rocks that we're working in here are about 3, 4, 5 million years older than the rocks that I in Wyoming last week. So we're kind of getting a nice little tour of the Cretaceous. In mid-July to early August, I'll be working in the Cedar Mountain Formation, the very beginning of the Cretaceous period, and rocks about 142 million years old. So yeah, we're getting a nice chunk of the Cretaceous this summer. It's funny how that works out. And Sussy999 says, have you ever been to the UK before? I went last November. Yeah, I was there for the Society of Vertebrate Paleontology conference, and then for a couple of field trips too. Got to go down to Dorset, visit Lyme Regis, which in some ways is kind of the birthplace of British paleontology. Got to see where Mary Anning used to live, often called the mother of paleontology. I got to go up to Oxford and see that famous dinosaur trackway there. That was really cool. And then got to hang out with a bunch of English paleontologists. That was a lot of fun. Kind of the trip of a lifetime in a lot of ways. And then I got to present research at the Society of Vertebrate Paleontology conference. So yeah, the UK is kind of the birthplace of dinosaur science, so it's pretty cool being able to visit. Found belemnites and potentially petrified wood. Oh, very cool, Sussy. Yeah, I found belemnites and ammonites, and I think even found an ichthyosaur tooth at one point on the beach at, that was at Charmouth. Cool stuff. Oh, and Akira Eclipse has got a great question. Oh man, you're speaking my language. This is the sort of thing the importance of paleontology. So I could talk about this all day. I became a paleontologist because I couldn't grow up to be a dinosaur. Which is to say, I don't know, paleontology is just cool. That's a big part of the draw for people like me, is we find it interesting. We get excited about this kind of thing. It's fun and cool, and there's nothing I'd rather be doing, you know? But at the same time, I think paleontology does have a huge value to society. The thing is, the study of fossils is really important because it gives us perspective that no other science really can. If we as human beings want to kind of understand our place in the universe and where we came from and, you know, what Earth was like long before us, what life was like on this planet before we evolved, paleontology is really the only way to do that. When we can look into the Earth's past and be able to understand all the critters that lived on this planet before us, how life has developed on this planet, it gives us a viewpoint that I think can be kind of humbling. We realize how recent we are as human beings. Like, we've only been around for about the last couple 100,000 years in the grand scheme of things. That's nothing. Dinosaurs, by contrast, first evolved about 240 million years ago, give or take. They were around until 66 million years ago. It's a long time. We're talking like 178 million years. And even dinosaurs are fairly recent when you think about the entire history of our planet Earth. It goes back about 4.5 billion years. In a way, studying paleontology and geology is kind of like looking up into the night sky and just seeing those thousands of stars, some of them hundreds of light years away, maybe. You know, you feel very small when you look up at the night sky and you see those stars. That's space, physical space. This is time, you know. We're thinking on that grand kind of scale, but just back in time. It gives you that transcendent feeling of smallness. I thrive on that. I know some people get really scared by it. I love it, and I think all of us working here in the quarry do too. But it also helps us understand how dynamic a planet we live on. You know, like Earth is constantly changing. The climate is changing, the continents themselves are shifting, mountain ranges push up and then get eroded down, landscapes change. That sort of perspective is really helpful too. I think we as human beings often don't do a good job of planning for the future or considering the consequences of our actions. We're used to thinking on a very short time scale. When you have this kind of information and you can think about how much our Earth has changed, I think it can make you a better person. When you're thinking about the ancient past and it makes you think of yourself as being part of this grand timeline, and how do our actions today, how will those snowball into the future? When we're thinking about things like man-made climate change, I mean, you see how gradual changes in the climate have caused catastrophes on our planet before, the extinction of entire groups of organisms. Then you think about what we're doing today and how much faster it is. It's really sobering. And then another example that I like to use is sometimes those changes happen really quickly, like at the end of the Cretaceous period, when all the dinosaurs went extinct, except for a few species of bird. That was because of a gigantic asteroid that hit the Earth. A huge rock the size of San Francisco, slamming into our planet, throwing up all kinds of dust and soot and causing global wildfires and tsunamis, and just, it was a bad time to be an Earthling. I think the reason why we as human beings understand how devastating an asteroid can be is because we've seen that happen through the rock record. You know, it's not just an academic thing. It's not like, oh yeah, I guess that would be bad. Like, no, that caused a mass extinction. It ended the reign of the dinosaurs. It tells us that we need to be on the lookout for big objects from outer space. You know, maybe through the world space programs, if we spot an incoming asteroid, and these things are being tracked all the time by astronomers. If we see one that we know is on a collision course with the Earth, maybe we can send up a rocket and deflect them, you know? I doubt there would as much concern about near-Earth objects like massive asteroids if we didn't have this science, if we didn't understand how devastating that's been to our planet before. So maybe someday there will be a giant asteroid like that, and maybe we as human beings can band together and send it off course so it's not heading toward Earth. That would mean, in a way, that we end up saving our species because we studied fossils, because we've learned the lessons of the past, so we won't be doomed to repeat them. Anyway, I hope that makes sense. It's just some musings here. But yeah. Anywho. And Gary and Kellis says archosaurs came before dinosaurs, but why are archosaurs not dinosaurs? Some of them are. Dinosaurs were a kind of archosaur. Yeah. But yeah. And here, I should go around the quarry and ask people why they are interested in paleontology, why they think it's important, I guess. I feel like it's a fun question. And Kote Ramada says, what organisms today do you think will fossilize for future explorers? Well, unfortunately, the majority of animals on our planet today are either humans or are livestock. Cattle, pigs, chickens. Here comes that wind, oh boy. So I think a huge number of future fossils will probably be cows, pigs, chickens, and maybe some humans here and there too. It's gonna be a pretty bland record for this time. But yeah. And how long has this site been known? Let's go ask that, Gary and Kellis, and then I'll ask some people in the quarry to talk about why they think paleontology is important. Steve, do you know when this site was discovered initially? This one here?
This site was discovered by Denver Fowler just about this time last year.
Oh wow,
So
okay.
He surface collected definitely 2 complete eggs.
Nice.
Some eggshell.
Uh-huh.
But I went in with our excavation permit this year.
Nice.
I expect we'll close out this year. You never know.
Cool, okay. It's a fairly recent site.
Yeah.
And then
Yeah.
I've got a question for anybody who wants to answer it too. In your opinion, why do you think paleontology is important? Why is this worth doing? You know, we see us scratching around in the dirt here. Why is this valuable for humanity? Lofty question, but I think it's a good one.
Why is it valuable for humanity? It's almost implicit to me, but I
Yeah.
have to. You know, we were discussing modes of preservation.
Yeah.
I think yesterday.
Uh-huh.
You know how all sorts of things have to line up
Yeah.
for eggs to be here.
Yeah.
You know, so we can be taking them out of the ground.
So like, what's preserving them? How does that happen?
Exactly. Well, how does preservation happen?
No,
or
just
like,
repeating your question.
Yeah,
Just
yeah, yeah, yeah.
paraphrasing it for the chat. Yeah.
And to me, understanding how millions of years can go by and these things can be often in almost perfect shape,
Yeah.
just kept in this time.
Uh-huh.
You know, the Judith River Formation or Upper Old Man in this case. It's so cool to me that process can happen and that we can study these things that lived long ago. Now we know we can't study all of them because you know we only preserved a small fraction, but so it's for me personally, I would characterize my career and my quest to do paleontology kind of like the old explorers of Everest do this. You know, like George Mallory, he said, it's just there and it's tall and I want to climb it. It's like I have this question that's been biting me for so long. Now, you know, a general audience kind of answer is this is a gateway for younger people to understand STEM and to get them into science. So that inevitably, you know, when the career comes around and you know, only 1 in 10 PhDs actually get these big full-time positions as paleontologists. That they'll be our future engineers, people in the pharmaceutical industry, like doctors. You know, all sorts of lines of work where you need to have a mastery of the scientific method. Sure. And then you can go and dig dinosaurs for fun. Yeah. You know. Yeah. It's a long-winded answer, but
it's a good one, though. I like that, Steve. Thank you. Yeah.
I'm sure somebody else has a.
Yeah, I want to put Brian on the spot actually, because I feel like he's going to have some insight here. We were talking earlier about the importance of science education, Brian, we had a question from the chat. Why is paleontology important? Like, why is it important that people like us are doing this sort of work? Like, what's the point for humanity? You know.
What's the point of studying biology or minerals, trees, anything? Humans are curious.
Yep.
And as we were talking on a ride out this morning, one of the things when I was teaching, I wanted to instill in my kids curiosity and critical thinking.
Yeah.
And if anybody, a kid from 3 to 93, they look at some of this stuff and they're going, what the heck?
Yeah.
How did this work? If you start asking questions about the world around you, you can get better at asking questions about your own life.
There you go.
And
Yeah.
the current world we live in, but this is a gateway to step into exploring things around you and asking questions.
I like that.
Yeah.
I like that a lot. Yeah. Well said. Yeah.
That was a nice try, Brian.
Well, that was the best I can do without a scriptwriter.
No, off the cuff, that was excellent. Thank you, Brian. Yeah. Yeah, and it's, I don't know. I don't want to be like too hoity-toity, lofty language about this sort of thing, but I do think it's really important, I hope it doesn't sound like I'm tooting my own horn too much, but like, I think this sort of work, like Steve was saying, it does help inspire future generations of not just scientists, but I don't know, historians, philosophers, medical doctors, chemists, librarians, like all the people that help us create new knowledge and hold on to that knowledge and teach other people about it. This is all kind of part of it, Like, I think when we're doing stuff that the public sees as really cool, like digging up dinosaurs, we're making knowledge seem cool and fun, because it is, We're helping kind of like sell that to the next generation, I guess.
And Danny, you ask, why this?
Yeah.
People can ask the same question of music,
Yeah.
literature, art, whatever. They all make our lives richer.
Yep. Well said. Yeah. And it doesn't have to be more complicated than that, I guess. Yeah. Yeah. Good stuff. So answers for you there, chat. Yeah. It's a piece of the puzzle of the tree of life. Exactly, yeah. Yeah. But yeah. Drunky Kong in the chat says, keep talking to that guy in the white shirt. I like him. Well, Brian here is, longtime science teacher and trained as an archaeologist. He knows his stuff. Can you tell us that story again real quick about when you went in for a medical appointment? You told me this morning.
Yeah, I needed vaccinations. I went to the county health department, and the woman took my my information and finished the paperwork. And she goes, "You probably don't remember me, but it's been about 30 years since you were my teacher." I said, "Okay." And granted, after 30 years, I didn't recognize her.
Sure, yeah.
Told me her name, and I think I remembered her. She goes, hate science, but I didn't like science in school. And I think this was 9th grade for her. I took your class. Science probably wouldn't have done it if it wasn't for you. So, yeah, it made me feel real good.
That's awesome. I mean, that is like some of the coolest feedback you can get. I mean, you changed her life. And yeah.
Well, that day
and now she like makes a career out of helping other people.
Yeah. That day she changed my life.
Yeah.
I mean, really.
Yeah. What goes around comes around, I guess. Yeah. Awesome. Yeah.
Well,
thanks, man. Yeah.
Thank you.
Yeah. Oh, and wait, did the signal cut out there? Oh, goodness. Did we miss part of it? Can you see and hear me right now, chat? Oh. All right, well, take two here. I think the signal for the satellite cut out just as you were getting to the punchline of that story there, Brian. You wouldn't mind retelling it.
The whole story, or just...
So you were there for a medical appointment, and then the nurse turned out to be...
Yeah, it turned out to be a former student from about 30 years ago, and she said, I really didn't like science. It didn't appeal to her. I doing science, not just learning
Yeah.
about what somebody else did. And, turns out she got excited about science and continued on in school and went on to become a nurse.
That's awesome.
So
So now she makes a career out of helping other people because you helped her as a student.
yeah, so it kind of changed her life, and hearing that story just kind of helped make mine that day. That's
Yeah.
for sure.
That's awesome. Thank you, Brian. I appreciate you repeating that. With the, hopefully we got that time. Sometimes the signal cuts out every once in a while. It does have to go to space and back. So, you know. But yeah, getting lots of thank yous in the chat, Brian. People love that story.
Appreciate it.
Yeah. Good stuff. Yeah.
Like orange.
Let's check in with Deanna over here. Oh, so she's getting down close to that level.
Yeah, it's ending. So it's
Oh,
a
the
natural
bone ended.
end.
Okay.
Yeah.
Yeah. Well, I wonder what that is. It's such a weird shape.
Yeah.
It almost looks pelvic. Yeah, so let me get my laser pointer out again. Not to shine in anybody's eyes, but to show the extent of the bone. So here's where it ends right here. It goes along like this. That's a really weird shape.
Right?
Huh. Bizarre. Oh, is it a really big vert? Is that the neural spine? And this is the centrum?
My hypothesis, like originally,
Yeah.
could be a vert, but if you let's see.
Here, do you want to point with the pointer?
Sure. I'm just trying to see what I saw.
Yeah.
Side here.
Uh-huh.
If it was a centrum, it's not really as thick as a centrum should be.
Oh, okay.
You know.
I didn't look at it from that side, yeah.
And then this should be the neural canal here, but
There's
it all
nothing
sort of
hollow.
melds together.
Weird.
I don't know if you can see it with the neural.
Well, let me move over to the side over here.
No, so,
Yeah,
scoot out.
it was.
Oh,
it
thank
was
you, Laura. Sorry.
Giving like
No, it's okay.
caudal vertebral with the
Oh,
neural
nice.
side.
Okay.
But and then you look at the cross section here.
Yeah, weird. Yeah, it looks totally
yeah,
different from
it's-
this angle.
It's not vertebral. And you,
What in the world?
down here you see some of it.
That's more bone right there?
Yeah. So
Oh.
this is matrix that will be removed to reveal more bone there.
Oh.
So
Could it be the distal end of like a big old limb bone that's been
It
broken
could
up?
be.
That's what
Could be.
That's what I think of.
Gotcha, okay.
That's what the
Yeah.
bones are.
Thank you. Yeah. Cool, weird. Really neat. Yeah. Well, shoot, again, when we're working out here in the field, this is the least information we'll ever have about that particular element or really any of this stuff. So we're finding new stuff all the time, but like our identifications and our concept of what's going on, it will change a bunch as we find more and more, well, as we study this more, you know? It is kind of like a funny game that we play when we're in the field, like trying to identify different bits and pieces. And when there's only a little bit of bone sticking out of the ground, you're like, well, what is this? You know, I think it might be, you know, part of an ischium, part of the hips, or, you know, is that a transverse process from a vertebra, or what is it? And like minute to minute, our concept of what it is will change as we find more of it. So it's important not to put too much credence into a field ID. I mean, we saw that back in Wyoming, where what we thought was a duckbill dinosaur site for years turned out to be a beautiful ceratopsian. When we flipped one of the jackets, and holy cow, there's a horn and a frill there. Yeah. Ugh. But that's why we bring these things back to the laboratory and clean them, you know? Yeah. A question from Elissa 2023. What's the you have found? Oh boy. Craziest thing I've found. I don't know how crazy it is, but one of the coolest things I found is what will hopefully be a new species of horned dinosaur back in 2012. The Danny Ceratops site. That's not the name of the dinosaur, it's the name of the site. Tomorrow we'll talk to Denver about that a little bit and see if he still wants to publish it as a new species. There was a Chasmosaur paper that came out the other week or month that they may have scooped us on it, but we'll see. But that was really cool. Working out here in the Judith River Formation near the town of Rudyard. I found a partial skeleton of a horned dinosaur. I'm hoping it's still going to be a new species, but we'll see. We may have gotten scooped. Yeah. Anyhow. And yeah, that is true, Claire. Yeah. 50 caliber shells. They weren't shells, they were slugs. So like the actual bullet part of the bullet, the part that would impact. The shell is the casing around it. But yeah. 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 Anywho, if we have any other questions, don't hesitate. We've got about another 40 minutes or so before we'll wrap up. So if you've got questions, now's the time. If anyone's just tuning in, welcome to Paleontologizing. Welcome to Montana. Welcome to the Judith River Formation, where a crew here is digging up some dinosaur eggs and bones and whatever else we find in this quarry. So, good stuff. Yeah. And Moose Not Mises says, oh, did you change your name? Moose Not Mises says, how do you move the fossils out of the field? Carefully. For this site in particular, the larger elements like the big eggs and the bones will put a protective plaster and burlap jacket around them to keep it from crumbling when we pull it out. And then that's kind of the protective, what we call field jacket. So when it gets brought back to the laboratory on a truck, even if it tumbles around a little bit, it won't be destroyed. For this site in particular, we're trying to figure out whether we'll take the jackets and carry them by hand or even drag them up the hill. But then on the other side, there's a gully and then there's kind of hills, so it's going to be a lot of work. Or maybe we'll be able to, if we get permission to use this little road over here, which I think might be on private land. There's a little pump station building down there by the lakeshore. So there's a road that goes up. I don't know if you can quite see. A little dirt road. We might be able to just drive a truck down there. And then that way we only have to carry the stuff mostly downhill. And then we can use a lift gate on the truck to get it onto the truck bed and then drive it away. So we're trying to figure out what our best strategy is here. But we'll get it sorted out. We'll figure it out. We'll get it done. That might well be after I've already left, or maybe it'll be while I'm still here over the next 8 days or so. We shall see. And Max Devlin says, would this site have been underwater back then? No, not at this time. So this represents a paleosol, which is like an ancient soil horizon. So this would have been dry land, but it would have been probably near a river. And so sometimes when you get a lot of rainfall, the river would overflow its banks temporarily and then dump a bunch of mud out onto the floodplain. And we think that's what happened here. We've got mudstone and we've got what is clearly like an ancient soil horizon. But we're not talking about under the ocean. This was, if there was any water covering it at any point, it would have been fresh water, if that makes sense. Yeah. So we're a bit inland from the western interior sea at this time. What you might be referring to is the WIS, the Western Interior Seaway. And it's not in here, I think it's in this one. Here we go. Hang on a second, Chad, let me find this for you. There we go. So, here's North America about 70 million years ago, give or take. And so this really should be running all the way through here. So there should be no land connecting Appalachia and Laramidia. But anyway, here is Montana. Here's the outline of Montana right here. So we're about right there. We're digging in rocks that are older than 70 million years, about 6 million years older, give or take. But we are near the shoreline of this ancient inland ocean, the Western Interior Seaway. But we're maybe a few dozen miles from the coast at this time. If you were to take a time machine and take off from this exact spot, go back 76 million years, this area would look quite different from what it does today. It would be pretty flat. This vast floodplain, kind of similar to, like I said, in Wyoming, kind of similar to like the Mississippi Delta or the Louisiana Bayou, maybe the Florida Everglades. So just vast, sweeping, flat vista like this. And there would be big meandering rivers going through, bigger than this one, that are dumping sediment from the growing Rocky Mountains to the west. And then to the east, you go a couple dozen miles that way, you'd be at the ocean, the Western Interior Seaway, which is a shallow, kind of warm, maybe semi-tropical sea, kind of like today's Caribbean Sea, or maybe like the Mediterranean, but warmer. That's the kind of environment we're talking about. And we're maybe a few dozen miles from the coast here, up like a big river delta system, where you'd have floodplain, soil, you know, really fertile habitat for all kinds of cool plants and animals, including a lot of dinosaurs. Does that make sense? Yeah. And Feynman diagram says, wait, where are the Rockies on that map? They're to the west. So I can show you again if you want to see. So the Rocky Mountains were just kind of starting to come up at this time. The Great Laramide Orogeny had just gotten underway. There we go. Whoop, other side. So here's the Rocky Mountains here. So they are to the west of where we are. We're about there. So in the current day, we're just south of the Canadian border, which is kind of, that's that dotted line, dashed line right here. Here's the outline of the state of Montana, like this. So we're about there. And the Rocky Mountains are coming up just to the west of us during the late Cretaceous. The Rocky Mountains were not as tall as they are today, I don't think, during the Cretaceous, but they are growing at this time. And that's what's causing... Well, we could talk with Denver about... tomorrow, when I'm at the other site, we can talk with Denver Fowler about sequence stratigraphy and accommodational space and how the rise of the mountains, you know, led to big basins here in the east. And all the sediment sloughing off of those mountains, all that sediment eroding away, came down those mountain streams and through those rivers and then was deposited down in the valleys here. That's what buried these dinosaurs and the other critters. It's a really cool, large-scale story, you know? There's so much going on there, and it's fun to talk about. And that was one of the subjects of Denver's thesis. His PhD was on the stratigraphy of these rocks and, you know, how the dinosaurs are evolving and how all of it kind of ties together. So I hope that makes sense. Yeah. And watching the hat. This is an Australian slouch hat. It's made of leather. I don't know if I want to tell you the exact make and model because this is not sponsored content. But we'll see, you know? I might reach out to the company and be like, hey, if you sponsor me, I'll tell everybody what kind of hat this is. So, sorry. Anywho. But yeah. Oh, and Andrew is there in the chat. How are you doing, Andrew? Howdy, howdy. I hope you're someplace less windy than me right now and warmer. But that's paleontologist from the St. George Dinosaur Discovery Site and Museum, Andrew Milner, there in the chat. I wonder if you'll recognize anybody here in the quarry, Andrew. with Steve? I'm not sure. We've got Andrew Milner in the chat saying hi from the St. George Museum. So,
How you doing?
Have you met Andrew before?
Oh, I don't think we've spoken in person.
Yeah, okay. But here's Steve Clausen from the Badlands Dinosaur Museum, Chief Preparator and crew chief out here.
Yep.
And yeah, Liz used to be director of the St. George. Hopefully we'll have Liz on camera in a couple days. But
And Andrew, I was out digging with you last year.
oh, that's right. Yeah, Brian, how are you doing? Yeah. So Andrew, hopefully you remember Brian here. I know there were a lot of people who came through there though.
Yeah.
Well, the camera's here and field people are here. I'm going to do
Ooh.
something that
Jacketing, yeah.
a lot of people don't like. Is what I'm going to do. And
Oh, soaking the
You want
burlap.
to do that with nice and slowly? Nice and slowly. Oh no, what am I doing?
Uh-oh.
Oh, that's really bad, isn't
Look
it?
how wet that burlap is getting.
Oh, it's going to get wet.
Why would you do that?
Yeah, exactly. Yeah, let's let that sit in there. Yep. We're gonna need a little. We're gonna need a lot more water for this. Yeah. Yes, we are.
So making what we call burlap tea, and then we'll all ritualistically take a swig.
It's definitely never happened.
Oh, Brian, Andrew says hello.
Need to come back and visit you.
Yeah. You've been all over the place, Brian. It's awesome. So yeah, this. Oh, sorry. Go ahead.
Let's say every year I volunteer to prep at a different museum and meet new people and
It's awesome.
see new stuff.
Living the dream.
Yeah.
So yeah, chat for context. There are a lot of paleontologists who would be cringing right now. This is. What is that big rivalry in it's like North and South Carolina, different kinds of barbecue? One of them has vinegar and one doesn't or whatever.
One of them is like mustard based or something.
This is kind of like that. We're like, do you soak your burlap while making a jacket or do you
Sit
not?
a little longer.
Are you supposed to like?
This is the way that I was taught with Museum of the Rockies, is we always soaked our burlap in water before making a jacket.
There are, a number of ways to make a jacket. You don't even need burlap.
Yeah.
I won't go into that too much, but what we want is working time.
Yeah.
Number one. These soaked. They wring them out. They're just enough to give the plaster a little more working time. Sorry, the plaster will get behind the burlap a little better. And it just.
How do we get rid of this?
I don't know. I do stuff with dry strips sometimes. Sometimes you just don't cut enough, and then
Sure.
you just throw a dry one on. Everything goes so fast, and
Yeah.
then it sets rougher than I'd like it to. Another thing I like is perfectly smooth, so hands don't get scraped and things
Right,
like
yeah.
that. So I will not believe that. I can't believe that soaking a strip and just wringing the heck out of it will significantly impact structural integrity, especially if you use layers and layers and layers. It's just, I think it's just a better way to do it. I don't know.
Rushwing in the chat says it sounds like the paleontological equivalent of if you put cream or jam first on your scone. And people would go to war over ideas like that, like it's happened.
I'm sure they would.
So this is kind of like that, yeah. I don't know. This is the way that I learned how to do it. This is how I was originally trained. So nobody in Utah seems to do it this way. So it's, I don't know. It feels like coming home saying this, you know. So what are we jacketing right now? Is it more of Brian's egg there?
Brian's egg.
Nice.
We're putting a top cap on, so it's not a complete jacket. We're just keeping all the rocks that are loose from falling down.
Gotcha,
We're
yeah.
keeping the egg protected from water.
So I'll show you what that means, Jack. So those of you who were here yesterday, hopefully caught a glimpse of this big beautiful egg here.
They're long. They should all cover with them.
And so he's got some separator on there already.
Let's start over the
And
edge, go over
We'll be
and
making that
And then in
protective
the
plastered
front.
burlap cocoon.
Well, yeah. So I'll grab some plaster.
Claire Burr wants to know, do we use oyster knives at this site?
Oh yeah, you'll see some here.
Yeah.
I bet Brian's got one right there.
There we go, yeah. Yeah. Again, I was trained on those too, but some of the Utah crews I've worked with are like, no, you can't bring that in the quarry. What are you talking about?
the gasket tool is really, really nice.
Gasket tool, interesting.
Yeah.
Huh. I've not used one of those before.
I haven't found any.
Who wouldn't bring an oyster knife into the field?
I don't know. I've worked with crews where they're like, no, they call them oyster shuckers, derisively.
Well, my view is if a tool works for someone, if you have field personnel who are being really effective, I'm not going to make them use an awl when an oyster knife is doing the work.
Yeah.
I don't use them very often. We have them here. I don't. I use bayonets.
Oh, yeah. Oh, man, look at that.
I'm sure there's a...
Oh. You know what? On a lot of crews, you tell them to fix bayonets, and that's a morale killer. That means some serious stuff's going to go down. But here, that's cool.
I don't like awls except for really tiny ones for fine things.
Right, yeah. Huh.
And not just any bayonet, that's a Glock field knife. It's one of the only ones that'll hand,
Oh, interesting. Yeah. Does it have like a metal pawling or whatever at the back?
Yeah, and it's got a really thick tine, steel tine.
Yeah.
Some tines, like, they cheap out and they're really slender through the handle, so the handle will just explode after less than a week. These are made well. Before they made guns, Glock made knives for decades and decades.
Okay.
So they're fundamentally a knife maker.
Wait, so you said this is a Glock right here?
Yeah, it's a Glock brand. it's close to the bottom of the blade.
Nice. Yeah, there we go. Glock. I gotta get me one of these, Steve.
They're nice.
Yeah, that is nice. Cool.
I suppose you could probably put it on one of their firearms. We don't do that here.
Montana. Gotta have the 10.
All right, so here Steve and Brian will be engaging in that time-honored paleo tradition of jacket making.
Yeah, we'll see if this is enough. I don't know.
So
some people will be upset by this as well. I was. So I was at the Field Museum a while. Burpee. I've gone to many places. Many different methodologies for plaster mixing. Some of it is very mixing it, and that's what I do with the hydrocal when I'm in the lab.
sure.
There's a measurement. It is slow,
and
you know when it's going to set. This stuff, we want it to set fairly quick. This is just simple plaster of Paris. There are different brands. Cookies. Sometimes they end up in there, and they're just, more.
Oh, okay.
Trying to get the consistency of pancake batter.
Yeah, I first went in the field with Denver back in 2012, and that was fun. Was walking around the Powder River Basin doing a Hell Creek survey.
Yeah.
And then I joined back with him in 2018. And the first time he went to plaster something, he just dumped the whole thing into the bucket. I was like, what are you doing? And so I'm sort of a hybrid of that.
Yeah.
I'm going to get a lot of it in here.
And this is how we do it with the Utah crews too. You make an island first.
Yeah.
And that way you know that you've got enough.
And you don't add water to the plaster, you add plaster to the water.
Exactly, yeah.
Well, keep going, buddy.
Yep, and see, this is, we got, put a lot more in there. Yep, we'll call that, we'll see what that does.
Nice. So this is how I'm used to doing it. You make it nice and thick, and then with the pre-soaked burlap, that adds a little bit of moisture.
It increases your working time.
Yeah.
The surface area of that burlap, this plaster, there's a certain surface area. It's a cloth. That doesn't help. That speeds up the setting of the plaster.
Sure, yeah.
A tiny bit more.
Yep.
I think so. I don't know about you.
Because the strips have little water in them, they're going to be a little thinner than this mix. So this is where I kind of that little handful.
Nice.
See if that does it.
Fistful of plaster. Ennio Morricone music playing right now.
I don't want to waste too much plaster. With plaster, I'm fine underestimating what we need. If we overestimate, then we can make a little figure or an idol or something, but it's really not cost effective. So this is ready.
Yeah, and if you've got an existing jacket, if you have some extra plaster, you can fill in the gap or whatever, but okay.
So what I'm going to do is take this rolled strip, I'm going to set it in here, roll it out so it gets plaster all on one side there, all on one side, then throw it in. You want pretty thorough, and
Yeah.
real speed that I
leave
quite a bit of it there. Yeah.
What's funny is that every time I show jacketing on stream, I don't know what it is about this microphone, but it really picks up like the squelching noises. Chat really likes that.
Yeah.
It's like it's way louder in the video than it is in real life.
I'll just say that sometimes when I talk about jacketing,
Yeah.
I have to filter myself.
Of course, yeah.
The way
There's lots of, yeah, for sure. We've got many kind of off-color terms for some of this stuff.
Let's just say I was early with Badland's Dinosaur Museum. I was helping film a promotional video for our Facebook and other social media. And I was told sometime later that all of my footage was completely unusable. Taken out of context. Trying to do a better job here.
Yeah. Oh, and thank you to Endymion. We're digging up some dinosaur eggs. This is how we make these protective, what we call field jackets. It's essentially like a plaster and burlap cocoon that we put around the specimens so that we can get them safely out of the ground without them crumbling.
Yeah, when people break an arm, they put a cast on it to keep the bones in their arm from moving around.
Yep.
We're doing the same thing, we're immobilizing.
Kind of deal. And this is essentially the same way that it's worked since the 1870s, when Othniel Charles Marsh's crews figured out how to do this back in the Wild West days during the Bone Wars.
All right.
So little has changed since then. And Gary Ankelis wants to know, have you ever run out of plaster or burlap? Oh yeah, both, many times.
Oh yeah.
It happens, you know?
But typically one or the other.
Yeah.
So there are many creative things you can do.
I've had to, take the shirt off my back before and cut it up in order to make a jacket when we run out of burlap.
Absolutely.
Yeah.
It's better to take the shirt off of one of your teammates and use theirs.
If you don't have enough plaster or separator, we use paper towels so we can separate the plaster from the fossil.
Yeah.
You run out of that, you just take some mud and just shove in all the cracks. You mud cake it.
Yep. Yeah, we've done that before too.
Here,
you use mud as separator? So there we go. So,
not to toot my own horn, but I think that was just the right amount.
Well done. Beautifully, I would say measured, but it's more eyeballed.
Smooth it out.
Yeah, I gotta smooth it.
Smooth as a baby's bottom.
It's appropriate for this site.
Oh yeah. Thought about that.
Good stuff. Again, thank you, Van Dimian, for the raid. I hope you had an excellent stream. It's good to have you here. Welcome to Paleontologizing. We're digging up dinosaur eggs and dinosaur bones and whatever else we find here. Nice. Yeah, look at oh wow. Wow. Deanna, what happened over here?
I did some trenching.
And found some more bones.
Bone
Holy
in the
cow.
trench.
Yeah.
What did you
That
do?
is a limb. That is
That looks like a
the humerus
chevron
right there.
to me. Wait, can you get it out of the plate? Oh, yeah, that's not a chevron. It's like a humerus.
Yeah,
I think
nice.
you're right.
So upper arm bone here. Very nice. Here, let me
what's the
point to
bone
it with the
there?
pointer.
What is that? That's a small I mean, that's all consistent with the The ribs and the verts we've been finding.
Right here, humerus, upper arm bone.
So are we discovering today that there is a rare growth stage of Lambeosaurus at this nesting site?
Or Corythosaurus.
Wow.
Could it be Corythosaurus? Do you get those here too?
Oh, so I'll say something maybe controversial.
Yeah.
You talk to Denver, he'll say Corythosaurus, Lambeosaurus, the same thing.
What?
Yeah.
Same animal?
So
That's a hot take.
That's a hot take there.
I don't know if individual variation goes that crazy.
Interesting. Huh.
But the dorsals I already identified as Lambeosaurus. It's Lambeosaurus.
Nice. Okay.
And the eggs are Lambeosaurian eggs. I can't call them Lambeosaurus because we had that discussion of Oataxa.
Yeah.
They're spherulithid eggs. So, and we do have embryonic bone here, and we find hatchling bone. This is something a little older.
Yeah.
I don't know, like yearling, but if that's a humerus, that does look like a humerus.
It really does look like a
That
humerus.
is a very interesting growth stage.
Yeah. Very cool. And we've got more bone right here too.
Crappy little.
And then we got to figure out
Little
what
rib.
that is. I mean,
And what's
that's
this
really-
big weird thing too?
I don't know. It's
Yeah.
probably from a way bigger
Strange.
growth stage. But
It almost
just-
looks like a
just cuts
distal
off.
end of a
Femur?
femur.
I was
Yeah.
thinking, I was just I'm like,
Yeah.
the end of a femur. That's a clean break, so the rest of it could be in the hill somewhere.
Break right here.
Yeah, an ancient break. The rest could be in the hill.
Uh huh. Sorry, I interrupted you, Dion.
No, you're good. You're good. It's just a crappy little rib.
Yeah.
That's everywhere.
Yeah. But beautiful humerus right
Honestly,
here.
yeah, really good preservation.
Really,
I'm
really
kinda
nice.
surprised.
You guys might have like a mountable specimen here.
That'd be sweet.
That'd be really cool.
I wonder if we're just going to keep. If it goes this way, then we're going to have to open up Corey here.
You're not going down this side.
Oh, we got a question. This might be a good one for you, Steve.
Yeah.
Is there any way to estimate the incubation period for a dinosaur species, looking at the eggs?
Ooh. I bet there could be. I wouldn't know.
Interesting, yeah.
I took on eggs. Just like because they came to me.
Yeah.
And
You found an
I
egg
have
site
this
and had
site
to
to
work
dig
it,
up, and so I call them the egg people.
Yeah.
These colleagues I have who've been working on eggs, through their PhDs. So I've been along for the ride. I'm a lot more interested in the chemistry
the same
than perhaps what was
same
happening
animal,
inside
or-
the egg. But what's great is that we can take the eggs back to our repository, our federal repository, and if you're a researcher who really wants to know all of that, they're going to be available for you.
Right.
Up until this point, most material like this, most Lambeosaurian eggs from the Judith, Upper Old Man, they're in private collections.
Right.
You can't access them. There are some at Museum of the Rockies, but with some exceptions, that's about it. So that's what's important. I don't know. I might not even care about some of these things,
Sure.
but I know somebody does. I want them to, and I want you to look at my eggs.
Right.
That's what it comes down to.
Well said. Yeah. Well, Dion is putting some sriracha on the bone right
You
there.
know it. Spicy lambio.
Well, that's some paraloid B72, our fossil glue.
This is a medium to thick mix, I'd say.
Okay.
But it cures pretty fast in the field.
That's such a cute little human.
I know.
That's lovely. Yeah. Really nice. We've got 478 people who are all oohing and ahhing over
All
this
right,
right
very cool.
now. Yeah.
Plus the 8 here.
Yeah.
No, that makes me happy. I was just down there jacking. I didn't know she was doing this.
That's awesome. Yeah.
No, I'm trying to trench, and there's a bone in the trench. It's that's just what happens.
Yep. Good problem to have.
Yeah.
Yeah.
Especially for
I
this
mean,
growth
this
stage.
growth stage is something our other side didn't have.
No, sir.
And now we're running into vertebrae, ribs, all from the same weird growth stage. So I would be hedging a bet that it's all one individual.
Oh, that'd be so sweet. We gotta start coming up with a nickname.
I'm not going to name it yet until it has a
Until a skull.
Yeah.
Yeah, good luck with that.
I'm
I mean,
tired of naming
Rod's
headless
duck still
dinosaurs.
Rod's duck still has a name, even though it's
Yeah,
lacking
well, we
a
didn't know
skull.
it was headless back then.
Yeah, very cool.
Yeah.
Pete B in the chat says, this is one of the first bones I've seen that even I might be able to spot. I mean, normally when I'm showing these things off, it's like, yeah, there's a brown blob. And like folks at home might not be able to really recognize it, but
That's got morphology.
yeah, pretty unmistakable. Nice, very nice.
Oh, you'll definitely run into more, so we're gonna start making another jacket.
Nice.
So in my mind, this is the jacket now, and that'll probably change. We'll probably run into more things, and it'll expand. And
It won't be a massive
like-
jacket, but it'll still be.
unless there's like a
Bulky.
sacrum right there and like a head right there, you never know.
I prepared enough.
Very cool.
I prepared enough sacred.
And they're in good shape. I mean, the brakes are clean on that femur. I'll call it a femur. So
Very crunchy.
yeah, this is cool.
Very,
More
very cool.
work, more work, but good for photogrammetry to have these exposed.
Oh, yeah, definitely.
Very true.
So when we know we're done, anybody have the time?
Yeah, right now it's 10 minutes to 5.
10 to 5. I say it's about time to get everything cleaned up
Okay.
and get everything out of the quarry so I can then leaf blow the quarry,
Nice,
which
grand
is
finale.
exactly what it sounds
Yeah.
like. Then Deanna will take a series of images for a couple different software programs. That's really cool.
Yeah. Derek, the marine biologist in the chat, wants to know how many sites do you work at? If you mean me in particular, well, goodness, this is my second field area I'm working in this summer. I was working kind of near Green River, Wyoming, last week, from the beginning of June until last week. And now I'm up near Havre, Montana. Later on in the summer, I'll be working near Moab, Utah, and then near Moab, Utah again, probably in September, or maybe October. So 4 different field areas, but each of these areas encompass different sites. So this is our double yolk site, is what it's called. We've got lambeosaur eggs, and now lambeosaur bones too, and some other critters in here. Tomorrow, hopefully, I'll be streaming from the Jack's Bone Bed site, which I think Jack Wilson discovered a few years ago. There's tyrannosaurs and hadrosaurs and pterosaurs and other critters from there. So, new site tomorrow. And then, those might be the 2 main sites from here. I'll be here for about the next 7 or 8 days. And, yeah. But all told, this summer, let's see, I worked at 4 different sites. In Wyoming, at least 2 here, so that's 6. Probably another 2 near Moab, and then a 3rd one. So, yeah, probably about 10 sites this year. 10 individual fossil sites. Maybe more, we'll see. But yeah.
I mean, we have a Jacob staff, I have a measuring tape.
Yeah.
Use the Jacob staff.
And Becca Paintmore says, do you guys use GNSS to survey locations or height of significant finds? We use GPS for this. I don't think we've got like nothing super high tech or expensive for logging the sites, like GPS coordinates. Yeah. So for other sites, you might want to total station or something like that. We have that at the Dolings Bowl sites in Utah, so I can talk about that later this summer if you're interested. But here, simple GPS is good enough. And then lots of photos of the site, and you'll see how some of the documentation works in a few minutes when we get this stuff cleaned up. We're going to do some photogrammetry here. Yeah. Calculus Centrifugal says a LiDAR drone would be awesome. We don't have that kind of money around here. And I'm not certain a drone could fly around in these high winds and not crash and burn. We had probably 40-mile-an-hour gusts earlier. Not the sort of environment you want to be flying a drone through, especially an expensive one.
Oh.
But yeah. And any way to see the mapping once it's all surveyed in? Once the papers get published, they'll be in the literature there, Becca Paintmore, so you can check those out then. But for right now, we don't really want to make it super public where we're at because we don't want to tempt any fossil poachers, if that makes sense. Here's that wind like I was talking about. And oh, you're also a GIS person? Awesome. GIS is really for fossil science. That's kind of a standard piece of advice that I give to anybody who wants to become a paleontologist. Like, if you want to make yourself marketable, if you want to be a good job candidate, that is one of the most important skill sets you can have, is GIS, Geographic Information Sciences. Learning how to make maps, learning how to survey things, learning how to use software like ArcGIS. It's not just important for paleontology, but so many different jobs nowadays. Whether you're fossil science, whether you're working in city government, in the planning department, anything like that, whether you're doing field biology or botany or whatever, GIS is one of those things that you can apply to almost any field. It's extremely important. Probably the best single skill set you could have, apart from like being able to write decently or read well. GIS is up there in terms of importance. It's the sort of thing that can get you a job. Just vital. And Derek, the marine biologist, says, is this site part of a park or can be visited? No, so you gotta cross private land in order to get here. And we have special permission to do that. And then this land here is public. We're working on Bureau of Reclamation land. So it's federally protected. We've got special permits to work here, but this is not a publicly accessible site. Unless you're watching it on Twitch. That's part of the reason why I'm doing this, to be able to, take this to the world and show you how this works in the least invasive way I can muster. So yeah. Finished my GIS degree and work in... Oh, very cool, Cthulhu Hates Hugs. That's awesome. Yeah. And Gary Ankela says, I didn't know that about GIS. I'm not going to say it's a well-kept secret, because it's not a secret, but it's something people don't realize, how important GIS is, what an incredibly marketable skill it is. It's, like I said, it's one of the most important skills that you can garner. And thank you, Confused Echidna. Yeah, we are in Montana, big sky country. Yeah. And Link for Real says the river running through that valley is so gorgeous. It's pretty nice, Even if it is a lot lower than it should be. You can see part of the riverbed exposed over there. But, yeah, we're lucky to be here. It's a pretty spot. It's also pretty windy. And there you go, Mighty Kingfisher. Yeah, they say I'm a wildlife biologist and work in ArcGIS Pro almost every day. Need to do analyses to comply with ESA and NEPA. Yep. See what I mean, chap? Yeah. And there you go, Derek. Yeah. I was lucky enough to learn some GIS in undergrad, and that was...
Yeah,
I don't know how many of those skills I really retain, but it hammered home the importance of GIS. That's something that I'll never forget. Oh, here we go. Bringing in the big guns.
Not ready for it quite yet. Yeah.
Oh man, that is serious. High caliber leaf blower there.
Can I take this bag back and bring it to the trailer?
Yes.
Okay.
Oh, and there he goes, Zanzibar. Yeah. Well, we don't have that kind of budget here. And I think some of this, that's the thing, is that most of the equipment that you're seeing at the site is like people's personal gear. So, backpacks, a lot of the digging equipment is stuff that folks brought from home. This leaf blower, does this belong to you, Steve?
That's my own leaf blower, yes.
Nice.
I don't use it for just this, but I find it's useful.
Yeah.
That's what you got to do sometimes.
Yep. Often on crews like this, the museum doesn't have a budget to provide people with gear. You got to bring your own.
I made a joke about.
And that extends to obviously our tents and stuff like that. We all bring from home.
We have the budget, but I'm not going to sit there and ask for a leaf blower just so we can blow off the site when technically we could get it all on our hands and knees.
Fair.
You know, but spend an hour doing what we can in,
Well said,
5
yeah.
minutes.
I didn't
So,
mean to denigrate the budget of the Badlands Dinosaur Museum.
just if
Yeah.
Mr. City Dickinson is watching right now, hats off to you.
Yeah, no, we really appreciate it. Like, it is pretty special to have a museum that is municipally funded. It's part of the city.
Yeah,
And
it's
that's
different.
That's pretty cool, you know? Like, it's... To be honest, I wouldn't really have much of a reason to visit the city of Dickinson, North Dakota, if it weren't for the museum. And it's cool to see that museum become more and more of a draw for tourists and other visitors, visiting researchers. Like, it's a contributor to the local economy, and it's a huge point of pride for the city.
And the city and the museum are sort of, we're all getting to understand each other. I mean,
Yeah.
we're all part of the same thing, obviously. But my director, when he started, it must have been 8 or 9 years ago, he said he had a conversation with our deputy city administrator, and she told him, I don't know much about museums. And he told her, I don't know much about municipal work. And so their goal was to get together and sort that through. And yeah, I think it's
beautiful.
being
Yeah.
thoroughly sorted through. Yeah.
That's really, really cool. Yeah. Yeah, so we're very grateful to the city government of Dickinson, North Dakota, and the people of Dickinson, North Dakota. These fossils that we're excavating will be there in that museum until the end of as long as there is a Dickinson, North Dakota. As a federal repository, they have special permission to be able to hold these fossils in the public trust forevermore, you know? And it's pretty cool that Dickinson gets to be the forever home of these fossils. It's something to be proud of, for sure. I remember when Denver Fowler first got hired to the museum back in 2015, I think? Or was it 2016? Yeah, it was just kind of a little rinky-dink museum. It had been closed for many years. It was opened as a dinosaur museum, I think. I don't remember if it was entirely private, but anyway, during the whole Jurassic Park craze of the 90s, the museum opened and was maybe mildly successful, and then closed later on. And the city decided they wanted to reopen it, and they hired Denver Fowler to be curator, and he's been, along with the help of people like Steve and Deanna and Liz and Destiny and a few other really cool folks, a number of other really cool folks, good number, they've been able to turn it into kind of a world-class institution. It continues to grow and expand. They've got this big expansion project going on right now. They're going to be more or less, I think, doubling the size of the museum.
It'll blow away.
This is going to be the envy of many other museums around the world, many other cities for that matter. So hats off to the good folks of Dickinson, North Dakota. Got some stuff to be proud of there. Here we go. So right now what Steve is doing is blowing away the dust and detritus
I can do it too if you want.
We can brush.
so that we can make a nice photogrammetric model. This is some data gathering that we do periodically. We use a smartphone and a nice 3D model.
Oh yeah, if I pay $150 a year.
Could you use your whisk room to
I put my
brush
whisk
some of
room
those?
away.
Yeah, you got to get it.
I've got one attached to my backpack over there. It's on the carabiner, the tan backpack by the gray scoop. That should be easily accessible. Just take the scoop off, it's right underneath.
Whoa, pristine.
That one's pretty new, yeah. Cthulhu Hates Hugs says, check their YouTube. Oh yeah, Steve does really, really cool stuff. What does it take to get a job like this? We'll ask him in a minute. But I think what he's going to say is a lot of field experience and a lot of fossil prep experience. It's the sort of thing that you can't really learn in a classroom. You just have to go out and do it. So Steve has been prepping fossils for decades. He's learned a lot. He's always learning more. I don't know. He's a team player. He gets along with people. He worked as a volunteer on these crews for a few years. And when the job opening came up, I think he was top of the list. We used to run into their crews up in the Hell Creek in the early 2010s. I'm not sure if they really knew what they were doing, but it's a legit museum, St. Louis Science Center. And Becca Paintmore says, does the photogrammetry go online anywhere? I don't think so, no. At least not until after this, until this stuff gets published. But there is an account on Sketchfab, I think, for the Badlands Dinosaur Museum. Somebody can provide a link to that. I think they've got some fossil mammal skulls and stuff up on there. Yeah. I think it's on Sketchfab. Oh, and it's the St. Louis Science Center is the one that I mentioned in Missouri. Yeah. So what Steve is trying to do is just create nice, clean surfaces.
Oh my God, Steve, what have you done? Covered it all with stuff.
Notice here too that we've been careful to dig drainage ditches away from the quarry, so if we get torrential rainfall, which sometimes happens here in Montana, this won't just turn into a big bathtub. The water will run down this drainage ditch and go down into the coulee. So we've got that here, and we've got that on the other side too, where Steve is standing, another drainage ditch. It's an important part of quarry engineering. You've got to give water a place to go. End up with a lake when you come back in the morning after a rainstorm. Nice. Is the pick there for scale?
So this is where we put the pick in each round of photogrammetry. It's a cursory capture reference marker.
Nice.
As is that scoop down there.
Nice.
And then we have to place one scoop down there.
Okay.
It's going to go to the left of that humerus.
Cool.
So Deanna can place the scoop. You can give this a little brush. You bring the scoop.
All right. I'll get my shadow out of the way. Here, I'll just stand on the other side. Put that up. They'll be use objects. There you go, Becca Paintmore, yeah. So you know a thing or two about this. Nice. This is something that's I've only really seen in the last few years. is photogrammetry being used at sites like this. Do you use like Polycam or Polycam? Nice.
Recently they updated it so that you can only take 150 pictures per capture, which sucks. Because I took a capture of a choking river, which is one of our other sites, and it had like 600 photos in it, and it was great. But I feel like 150 just isn't enough, so we'll have to
take more than 150 for meta shape.
Yeah.
Okay.
So I can add a bunch of extra ones
Nice.
into a different program.
Do you ever use Scaniverse?
I heard about that.
I think it's only for iPhone, unfortunately.
I'm not sure.
I've got an Android and it doesn't work. Or at least last time I tried, didn't work.
Scaniverse, and I've got Scaniverse, Reality Scan, Polycam.
Okay.
Yeah, Scaniverse is. I've seen some other captures and they're kind of mid.
Yeah.
Like when you zoom in, it's not very detailed.
Oh, interesting. Okay.
Because like textures, like what you see in the photos, look really good. But once you pull back to the material capture and just see it as like a blob, it's, there's no discernible shapes.
Fair. And let's see. Mayor Spaces. Good thing you blew away all that dirt off your dirt.
Yep.
That's what we do. Yeah. So Dion is making a photogrammetric scan of this.
Burn leaves. The leaves are a little wet. It's like, oh yeah, this will get it going.
And Zanzibar's, is this like the stuff they use for rendering sets from live locations in filmmaking? It probably is. I'm not totally sure.
Blow the dust off the gravel into your neighbor's yard. It's just like,
And they get paid by the neighbors to blow it right back.
Shark Geek in the chat says, my dog was barking. He thought the leaf blower was outside the house.
That's great.
Audio is that good.
Oh, so like in future scans, they'll try and position them in the same way for reference?
Yeah, I mean approximately.
Yeah, hopefully they're still all standing.
I don't know if this fast was when it got really crazy yesterday. It just has been going on.
Yeah, it never ends. Is it windy in Puerto Rico? Is it like this? During hurricane? Ontogeny. But normally,
this isn't a replacement for like a traditional grid map. This is supplemental to our grid map. So you may have seen a lot of measuring tools around here.
Yep.
We map properly, and we have that on a two-dimensional grid. And I do get the Z's for the eggs, so I have a arbitrary datum, and I think it's about 58 centimeters between the lowest egg and the highest egg.
That's a lot of distance, a lot of vertical distance.
We take those numbers, but sometimes we forget something here or there, and the photogrammetric model can help us establish that, especially after we enter them as metadata. So it all goes together, and it also creates what Joe Peters and I coined back in 2018, I think it was, a living map.
Right.
And that you can watch the quarry just evolve, and you know what was taken out when. If there's an unlabeled jacket in your collections, you'll have this file.
Right, you can match it up to
there
it.
It is.
Yeah,
That's where we pulled it out.
Nice. That's cool.
I had it under the.
Yeah, different crews do these things differently. Like other crews that I work with, we have like a whole datum system with like quarry nails that are in. You measure out 1 meter from each one and all that stuff. And that works for certain sites. For something like this, I can see how this definitely has its advantages.
Yeah.
Yeah.
So I used to do really hardcore photogrammetry. Like, I mean, things that the technology has evolved. Like, the quality of the models we get now are about what we were getting in 2018 with thousands of photographs, an SLR camera with just the right settings, 3 rounds, you know, it's facing the ground at 90 degrees. These technology
from Wyoming,
developed. So I, to her and then Joe Peterson and I established this mapping technique for the Cleveland Lake Quarry. These days it's a lot easier to make a simple photogrammetric model
just with a phone.
Yeah that can't be all. Like you do need a grid map, but when you combine the two, all of a sudden the nitty-gritty stuff in the quarry, like a nail every 4 inches, generally doesn't matter. Unless like you're really trying to pull something like qualifying the position of bones relative to each other to try to interpret whether there's a flow direction that's pushing them one way or another. You know, this data, you'll be able to do that. It's not correct millimeter by millimeter, but you know, we dig big quarries here. This is my first couple this summer, and it's already getting more complicated. Wanted to get done by the 25th, but that's not happening.
Oh shoot! Okay.
But it's normal.
So this will be going until after I leave.
Yeah.
Nice.
Yeah, I'm just taking extra pictures for uploading it to. What program do we use on the computer?
We use Metashape. It used to be Agisoft PhotoScan, and then they went and they changed the name to Metashape.
Yeah, I've used, what is it, Mesh Mixer or something like that?
I think you can do it in Mesh Mixer. I haven't done anything outside of Metashape or these apps here. I mean, I have a couple co-authored papers. This is so long ago. You know, now it's so much easier that it almost feels like cheating.
Yeah, it doesn't take any skill anymore. Alright, we're good.
Nice.
There's some photogrammetry person out there that's waving their hand. It doesn't take any skill.
But no, we've got some photogrammetry people in the chat, and they're like, "Oh, it's so cool to see this." Yeah. Neat. Awesome.
Alright, that's extra 270 in addition to the 150, which is not a lot, but...
I haven't actually get close to this bone.
I got
Yeah, let me take a look up close with that too. A classic hadrosaur humerus right there. Really nice.
It's really fat here.
Yeah, that is weird.
I could see it being a femur, but it would be oversized for this growth stage.
It would be. It's probably a different individual.
It could be.
I would imagine.
Yeah.
I can't see what else it could be other than like distal end of a femur. Maybe it wouldn't be a tib. That's got to be the knee joint.
Yeah.
Yeah.
Yeah, I would lean on femur for that. And there are clean ancient breaks, so there could be more anywhere all through here. But I mean, this is really cool.
Yeah.
Just having that, just having this humerus.
Yeah.
It's just so small.
And they could be fairly diagnostic, right? Like lambeosaurines and saurolophines have got different shaped humeri, I think.
Yeah.
It's
Totally
a good bone to have.
Well, that's cool.
Yeah.
And there's something there. That one's not nothing. That's a complete something.
Delta Dromius Deb, welcome to the chat. Good to see you. And a little hadrosaur humerus right there. Doom Kitty, first time chatter, says, this is so cool. Welcome, welcome. It's good to have you here.
That is awesome.
Yeah.
Yeah.
By the way, while I've got Steve here, should say, follow FossilPreparator on Twitch. That's his channel.
That's my channel. It's not our museum's channel, but you know, once I leave the museum at the end of the day, I'm still bored and I want to prepare fossils. And I don't always get to prepare fossils all day, you know, just in, you know, all this expansion things going on, and managing volunteers. So I go home and I work on fossils in a lab that I built with Diana. And I figured maybe I'll stream some things, and that's what I did when I started the Twitch. I didn't think much of it, but it got some traction, and you know, I've enjoyed the interactions I've had there. I just have to I had to build a new lab. I bought a house, and then I went to the field. So I plan to be doing it in September. I'll just turn on that live button and see what equipment is failing.
That's how you do it. That's how you do a live stream, you know? Because things won't fail until you're live, so got to click that live button.
Yep.
Yeah.
Really cool stuff today. I mean, I'm not trying to ham it up for the camera. This is really awesome.
This is really cool.
Yeah.
No, it's got to be the most beautiful thing we've seen in the quarry so far. Even prettier than the big egg. Becca Paintmore says, can you ask FossilPreparator to stream during when Europeans are awake?
And what time slots would those be?
Might be in the morning,
I do have a weird time slot, so I'll do my same two. I was doing Thursdays. This is in Mountain Time, roughly 6 Mountain Time. I'll up until 9 or 10 or whatever. You know. But then Saturdays, Sunday nights, I was doing like roughly 10 or 11 p.m. till 4 a.m. So I have a lot of people from New Zealand, a lot of people from Australia.
Nice.
Just a unique.
Yeah.
I'm up pretty late. You know, during the week. I'm a night owl, so I'll sit there and work on fossils. And I did it for so long, just by myself. Yeah. You know, and then Diana comes in every once in a while. She goes to bed at normal hours because you know, I'm strange. But if I have a suggestion for a time slot, it's something that I can keep in mind. It's just, I think, you know, 2 streams a week is something that I can handle. Yeah. You know, while also doing all of this. You know, so we'll just have to feel it out.
Awesome. Yeah. That's so funny because like people ask me to stream at different times and I go, no, I'm not going to do that. Like, not rearrange my life. Like, I've got things going on, but I appreciate your being open to that.
I'm not promising anything.
Yeah.
You know, we have to see.
Getting a lot of praise in the chat too. Kenneth Ye says, I love this guy so much.
I love you too, man. That's why I'm doing this.
Yeah. Nice. But yeah, man, it's been a fun stream today. You know, I had a choice between going to town today for, you know, town day, and coming back out here to dig, and I'm really glad I chose to come out here and dig. It's been a really good stream, and yeah, it's been a lot of fun. I think we're going to wrap things up in just a minute, chat. So if you have any other last questions, speak now or forever hold your peace. We'll wrap things up here. But yeah, there you go, Mr. Twinkie. Anyhow, and it's been exciting. Yeah, we've seen some good stuff, Golganek. This has been cool. Hoping to have even more fossils to show off on tomorrow's stream from the Jack's Bone Bed site. We've got multiple different dinosaur species. We might even get lucky and see a pterosaur element. All kinds of cool stuff for tomorrow, I'm hoping. But yeah. For right now, I think we'll go ahead and wrap things up. And hopefully we haven't depleted too much of the battery. Solar panels weren't of much use today. I had to position them like this so they wouldn't blow away. And it's been kind of cloudy, so anyhow, hopefully we get some more sun in the morning. Don't go away just yet. We're going to raid into somebody else doing some science here on Twitch. Let's see. Live doing some science. Rhacodactylus is well, is hoping to go full time with streaming, and as a fellow scientist, he also does science here. Cognitive scientist, studying why people believe weird things, from like urban legends and internet rumor theories and stuff. He studies what compels people to believe that stuff. You know, how do we combat misinformation and teach people good information? So we're gonna go right into Rayco. Here we go. Rayco _ Dactylus. There we go. Excellent. Yeah. The chat is saying thank you for the stream, everybody. You were great today. Really appreciate it. I really enjoyed watching it. Yeah. And thank you, Steve. Chat is saying great stream. Thank you very much. Yeah, he's busy right now. Don't worry. You're all good.
Thank you, guys.
Yeah.
I appreciate it. Maybe you'll be back for this to be flipped. And
I hope so. Yeah. Yeah. But for now, thank you for being here, everybody. Really appreciate your time and your attention. The internet is a big place. Thanks for spending time with us out here in Montana, digging up dinosaurs and doing science. We're going to continue the science with Rhacodactylus. Thank you to everybody who watched today, who contributed financially. It's the reason I can do this. I appreciate that very much. Thank you to the moderators for keeping this a safe and wholesome and welcoming environment for everybody. I'll be streaming again from a different site tomorrow, looks like. So tune in then to see what that's like. And let's go check out Rayco. All right. Take care, everybody. Bye-bye.